A very good morning to one and all present here. We hope you all had a great start to the week with yesterday's insightful sessions. I, Dr. Aruna Bansal, with my co-fellow Engineer Ritu Sharma, welcome you all to day 2 of our AICT Atal FDP on Advanced Emerging Technologies, Applications and Future Prospects, hosted by Department of Electronics and Communication Engineering, Subharti Institute of Technology and Engineering, Swami Vivekanand Subharti University. Today, we have an exciting lineup of sessions focusing on sustainable technologies and industrial advancements. Without further delay, let's commence with the first session of the day. Please welcome Dr. Avdesh Singh Pundir, Manager IC at ChemEd, associated with JGC CNC Limited, Japan, with over 17 years of professional expertise. Welcome, sir. May I now request Professor Shravan Kumar Kansar to kindly come forward and present and welcome our key speaker for today. Thank you so much, sir. We are very honored to have you today. Professor Avdesh will be speaking on process modeling and control using MATLAB S-Pen, offering the practical insight into industrial applications of simulation tools. Now it's my privilege to introduce the esteemed today's session speaker, Dr. Avdesh Singh Pundir. Dr. Avdesh Singh Pundir is a distinguished professional in the field of chemical engineering with a PhD in chemical process modeling and control from the prestigious MNIT Jaipur. Currently, he serves in domain of business development and technical services at ChemEd India, Delhi, and it's associated with JGC Catalysts and Chemicals India Private Limited. With over 10 years of academic experience and 5 years in industry, Dr. Pundir has made significant contributions to both teaching and research. His areas of interest include process modeling and control, computational methods, and project-oriented chemical engineering work. Dr. Pundir has published 10 international and 15 national papers and is the inventor of 4 published patents, including innovations like the automatic hose pipe wrapping device and workpiece joining device. He has actively participated in numerous national and international conferences, webinars and FDPs, and has also organized several impactful webinars on current trends in chemical engineering. As a co-principal investigator, Dr. Pundir has worked on several government-funded projects, research proposals related to industrial wastewater treatment and process optimization submitted to agencies like SERV, DBT and MODROPS. In addition to his academic and research pursuits, Dr. Pundir has served on various institutional committees, including those for admissions, examination and accreditation processes, and is the currently NB coordinator of the department. We are honored to have Dr. Avdesh Singh Pundir as today's sessional speaker, and we look forward to gaining from his rich experience and insights. Please join me in welcoming him with a warm round of applause.
Good morning. Technical service to the refineries, for example, IUCL, BPCL, HPCL, HRRR, Rajasthan, etc., etc. And today, before starting this topic on process modeling and simulation, it is very broad area and has very practical importance. And these are various content which I am going to little bit try to touch, because no one get perfect in one day in process modeling and simulation. It require many years of practice, because a lot than just theoretical description, it required a lot of observation, experience, how to analyze the problem. And I will try to not just initially touch the theoretical portion. I will try little bit show you little bit experimental data of the plant. However, it is proprietary to our company, so that's why I'm not showing all, but just show you a glimpse how actually. In introductions, I will try to touch why we need process modeling, what terminology basically used, and various process in chemical engineering, because my background is chemical engineer. So little bit I will more inclined towards chemical engineering. and what is different level of studies normally in engineering we normally do, and how it will help to get whenever you go to post it to some organizations, and what degree of freedom analysis. It is a part of process modeling, because before, whenever we try to do something, we should know at least what is going to happen, or it is soluble or not soluble. It is just kind of initially diagnosis of the problem. And common task for engineers, more especially to chemical, different simulation tool, because in our classroom teaching it is okay to explain things by hand calculation, but whenever we have a lot of data, a lot of industrial equipment, it is very difficult to do by hand, so we will have to take some tool. There are various tools available in the market, and we select the tool as per our requirement. In this discussion onward, I will try from very basic and try to increase level step by step up to certain level. So I will start from general equations. These are basically non-linear. However, it can be easily solved by hand if it is one or two equation, but if it is more than 100, it is not advisable to go by hand. Similarly, few basic calculations for demonstration purpose only: vapor pressure calculation, bubble and dew points, batch distillations, and whenever we come to the real problem, then we come into 3D equations. There are so many automatic tools available which normally try to solve directly 3D equation, but I will drive them by hand so that we have some background, and once we have background, then we easily handle that software, and we come to know before starting what is going to come if I am using this kind of software. For example, mass, momentum and energy. Before actually going to modeling, I will just want to show how the actual plant look like. It looks like crap kind of things. However, photos taken are not allowable, but it is published in journal. That's why I have taken from that. Similarly, this is kind of, separation unit, how it look like. It is more than 20 meter tall. This is, for example, right now I am deploying to this unit, supplying catalyst to this, that is called fluid catalytic cracking unit. Normally, what is the role of this unit? This unit is basically produce motor spirit, gasoline, propylene yield. Propylene yield basically means that we use them for making polymers, different grade of polymers. And propylene PP is mostly has large consumptions other than petrol, diesels. And it is the actual picture how the plant look like. And whenever you deploy to some organization, they ask you to do the modeling for this one. However, you have to take many advanced tools to do the modeling and control of this one, but that require a lot of experience. It's not just a single 1 year or 2 year game. We simplify it in this simple diagram just for understanding purpose, how it will going to come whenever we try. Similarly, this is some, this data will give you a little bit glimpse of what you are going to face whenever you analyze the data. We have to analyze the data, for example, particle size distribution. Whenever we put something, we have to analyze how the particle behave actually. So if you see in this particular row, it is 0, 0, 0, 0 means that what is going on, 1, 1, 1, 5, 5, 5. You have to extract the information by analyzing this mathematical data. So normally we frame so many models and try to fit that data and see our model is behaving the similar pattern as the data is showing. This is all data. What is the chemical composition it has? It should be approximately not just same, but near about 2830, 29 something, something, something. And these are various other components. Similarly, when we get data from the plant, our job is, for example, to analysis in the month of December 24, the conversion is fall below the baseline, that is 70%. And that is the bandwidth through which you are allowing for some component yield. This is particularly related to the gasoline. Gasoline means you understand it look like petrol. So gasoline yield should be above 70% if you are supplying some chemical component to some organization, and if it is falling below, then my role come into the picture to analyze the data and find out what's the going on. Similarly, when the conversion is going down in the month of December, you have to see there is little bit hirement in other trapment, that is nickel. So we come to know that whenever the catalyst surface is fully occupied by some foreigner material, nickel and vanadium, they are destructive material for petroleum cracking, it yield is going down. So I got first hint, it is due to foreigner particle nickel, that is part per million. Similarly, whenever we see here, when this particle is deposited on outer surface, what will happen to the total surface area? In the month of December, it is drastically fall down. It means that this was the culprit, and due to that one, conversion means that more rupees. Petrol are very costly, propylene is very costly, diesel is very costly. If it is going down, because it is not just a 1 kg or 2 kg, it is 1000 metric ton, for example 5600 metric ton per hour. And if this scenario is remain for the whole month, you can analyze how much cost is going to pay by the industry. And they ask us what we are doing here. So it is now our day and night job to analyze the data. This is just a glimpsing before starting the process modeling, so that you can come to know what is actual problem and what you are going to need. Similarly, for example, because this overall conversion is getting down, so this particular gasoline yield, that is 55, is again getting down. And here you can see in the month of December, iron content is again deposited other than this one. And similarly here you can see, however, this is again a culprit. Coke cover outer surface area of any catalysis, and it stop exposure to some other conversion material. Due to that one, the contact will not happen, reaction will go down. Coke is also one of the culprit, but here it shows that it is right now in a correct position. So we believe that these two particles are so and so on for more responsible for degradation. Similarly, many parameters. It's just I told before, it is not just 1, 2, 3, 4. It is more than 20 parameters which simultaneously interconnected. That is why we call dependent equation. So it's very difficult practically. It requires a lot of experience to analyze this data, how to relate them. And organization asked you to normally, funny part is to calculate the losses to find out the true diagnosis of this system within 2 and 3 days. So you have to work a lot in the midnight as well. Similarly, if you come to see, they ask us to prepare some component just precise to this matrix. It contains a lot of parameters. We call them constraint. Constraint means that what you can do, what you cannot do, what you can do, what you cannot do. At every step they need to correct you. For example, iteration index is basically how the catalyst, that is solid particle, it dissolve out whenever it flowed along with the petroleum product. But it should not, you cannot provide maximum value beyond 4. However, practically it is 4 to 6, but they have mentioned here 4, and for the commercial lot it is maximum value 3. These are just examples so that you can come to know that how the modeling come into the picture, what is its significance, and how we analyze the data. So you can see a lot of constraints are there. And these are the product. If all of these, you can see our product is that has the highest cost, 66,504 rupees per metric ton. So earlier picture I have just shown the gasoline is going down, that has the price is per metric ton is 66,000. So if you imagine, if this process still continue for even for few hours, how many loss you are going to pay. So you have to taken care. And other than this one, as per I described previously, for example, if your supplied product is not as per their requirement, you have to pay the penalty. Yes, they have set up the constraint, but constraint is not just a warning. It will come in terms of heavy dues. You have to pay. Okay. For example, if they ask कि LOI should not go beyond, for example, 12 or 15, and you are within the range, then it is okay. If it is beyond the range, then they put the penalty either in term of new material or either in term of some rupees or currency. And again, it is a headache for the manufacturer or industrialist, because whenever we supply product to government organizations, they strictly follow the regulations, and we have to adhere to what the characteristics they have published. And when you apply or supply something to some organization, they have some recipe to evaluate you. Whenever we have different vendors, so they will calculate the net value additions. For example, whenever we try to teach a course, so normally nowadays NAAC or NAAC ranking normally ask how much value do you add during routine classroom teaching. So just teaching course is not sufficient. How much additional value you have given to the student does matter, and thus accountability comes through NAAC or through NAAC ranking. That's why these bodies are generated. So similarly, whenever we go to select some vendor or some manufacturer, they have their own. What is the price of product? How much amount is they are using? How much feed prices, consumptions? How much daily catalyst dosing is required? So and so on. So all this picture, whenever you have in mind, this is one example because I belong to chemical environment. So that's why this is more stuff in chemical. But it is overall scenario ki you had to evaluate something, you have to put a penalty if you are not bound with the constraint, and these are the prices which come into the picture, and it is very huge prices. These are few picture whenever we, however, automatic system is visualization through DSC, decentralization control room. Pictures are not allowed, but I have taken few just for demonstration purpose. And similarly, when we try to visit, it's very difficult to visit even inside this one. A lot of crowded, constraint, you cannot move freely, but you have to go at least 2 and 3 times to see actual picture, what is going on there, because everything is you cannot extract directly from the data. You need to see what the physical picture of that particular organization. So you have to move there, and that is difficult. Again, you are bound with many regulations. Now, after all seeing all this real-time scenario, now I will try to introduce little bit about introduction kind of thing, because in 1 or 2 hours you cannot be master anything, but you have something in your mind so that later on you can visualize it. As I told earlier, my discussion is not very high experimental data, because earlier or many times I have also attended many courses for process modeling and simulation. Normally people start from their research and their result. They discuss that result with others, and that I don't think so have much full usefulness, because other person don't have the same research domain area to discuss. That will not be very fruitful. That's why I will start from very basics, so that this knowledge you can fit in your domain and try to find out something that is related to your domain. That would be more useful, I think. For understanding what is modeling, what is simulation part, how you describe process modeling of any kind. Process modeling just not related to the chemical engineering. However, it is a part of curriculum of chemical engineering, but it's not just related to it, is everywhere. Environment, everything you want to predict, then modeling come into the picture. In modeling, we just build the model, but we cannot get anything. That's why the next part is simulation. That's why the whole phrase modeling and simulation come into the picture. We call this process modeling, and then result is published through simulation. And similarly, different model strategy, we have different type of model lumped distributed parameter. Real time is distributed parameter model, and that is very tough. That requires a lot of data, a lot of equation. I will come to that little bit. How to apply some equation, mass or energy balance, that is essential. Mass and energy balance you can apply on this room. How much cold air and hot air is coming in this side, how much we are accumulating, throwing out, how much temperature it is increasing, how much it is going vent side. So through this one you can calculate the heat load of this particular room right now. That is again a process modeling of this room. Similarly, there is advanced courses like process modeling of buildings. In metro cities, they calculate the heat load of the building. Similarly, these are some few important properties. I like them very much. This I will demonstrate everywhere. I go and explain bubble point, dew point, flash point. That is very important property for. So as I describe, basically modeling is important for research as well as industrial day-to-day activity, just like I demonstrated earlier. Why we are interested to do modeling? Because it reduces cost. How to reduce cost? If you want to check something, we check it first theoretically. For example, if you want to construct some plant for manufacturing some XYZ, you cannot first just go there and construct the plant and see कि whatever product will come, it will suit to the industry or outside market. No, we will first analysis all this one through paper and pen. Once we convince on paper, then we'll try to build some equation model with the help of some software and try to see what is going to come. That is second step. Third step, once we convince enough कि okay, it will come up to the mark, then we'll try to validate the model along with the already available data, either in published in research literature or available in some other resources, and then we can able to come to know कि plant will run or not. So it means that it will save time as well as cost, but it need a lot of data. OC means operating conditions to run the model, because running model required a lot of data. All data are not published because it is proprieties. Just like this one, this is not available in any research article because it is a company proprieties, and it is under our regulation. We cannot show them in public domain because it is our research data. So this data is not easily available in the market. You have to generate your own. And once these tools are very useful to understand the process, because देखिए, when we build model, it is based upon some principle. For example, material balance. अब material balance में हमको मालूम है, we come to know that कि how much amount is coming inside, how much going to out. What we can measure normally in normal practice, in and out we can easily measure. For example, if you get fever, what you normally do? Put a thermometer in mouth and note the temperature. What we try to diagnose what is going on inside. However, we are not doctor, but we come to know if fever is coming up and down, up and down. In a cyclic motion, we call it viral fever. Okay, so we analyze the data, diagnose the problem. Initially phase, we put some medicine, for example, paracetamol. If it is a viral, you know, amoxicillin trihydrate and sulfaxime oxtal and proxil. All these are medical. I already know all this medical because in the earlier started in 2000, I was a production chemist in pharma company. So I manufacture all these. That's why I know all them. So we try to understand the behavior and behavior in terms of dynamics. So normally in literature you will find two words. Sometimes they said it is a steady state behavior. देखिए, all terms are related to our daily life. Steady state behavior or dynamic. अगर example, my mood is swimming. For abhi I was angry, little bit time I was happy. Then it is dynamic, because as per watch, it is up and down. The things which is vary as per time, we call dynamic. If something is throughout the day same, then we call it steady state. Throughout the day means that here the time parameter is remain independent what the process output saying. Okay, up to now you heard many times the word modeling, which is nothing, just a mathematical arrangement of some equation, that we call it mathematical model, Different equation means there are many types of equations. Some are algebraic expression that has addition and subtraction. Some is ordinary differential equation, and some are partial differential equation. And combinedly, we call them system, because a real-time system is a very complex. It contains, I assume, more than 100 equations along with a lot of data. That's why you need to simulate them by using some computer tool, because it is not feasible to solve them by hand. But here, for demonstration purpose, initially I started some simple equations so that you can go and try at your home to solve your problem by using them, so it will be helpful. Now, if somebody asks you, like they asked me, to do the modeling for this complex system, so this is standard pattern normally. We try to cover up what is real problem. To analyze the real problem, analysis of data is the first step, but it is not all step. You have to visit the site and see what's actually going on there, and try to simplify, because we cannot keep everything in the picture, because otherwise it will so large, it will be difficult to solve. We try to simplify it by making some assumptions. Assumptions are the things which we assume it is in the form which we are accepting them to be. For example, right now I'm assuming the room temperature for the next 1 hour of this room is approximately constant. However, it is true, because there is no flowing air and in and out suddenly, so temperature will be constant. So the assumption right now I am making, that is suitable to the practical things. So in the similar manner, we assume many things to simplify the complex system to somehow, so that we can arrange something. And we try to build something in mathematical form. Later I will describe how we can build. Try to solve them, some tool, and see what is the solution of this problem, okay? And checking the feasibility, because many times I heard that AI will replace human being or computer will replace human being. No, it is not possible. We are using simulation for many years, and till date I don't think so it has capability to replace human. Nobody can replace human. However, they can reduce workload up to certain extent, but it cannot replace us actually, because we come here. It is just do some coding simulations kind of thing, simulation output. It will just throw out some numbers, and you are there to tell them, the organization, what has its physical significance or not. For example, if you do the temperature calculation and it is showing the room temperature is, for example, 130 degrees centigrade, so you know it is not possible, because it should be within the range of 30 degrees centigrade. So that's why human being come into the picture to check the feasibility of data, whatever is coming out through any simulation. And if it is no, you have to go to again. And many times it's come into this domain. And this is again a very hard work. But whenever you get experience for 10 to 12 years, then this work is little bit less, then you are able to solve that model. Okay, solution of mathematical means that, for example, to simplify the data, normally we convert into dimensionless form. For example, in control, normally we do not care what is the steady state, because control system come into the picture when something is disturbing. If something, for example, moving in this horizontal line, it will not disturb us. But whenever it come to, just like I am showing the data, up and down, then the problem will come. So sometime we have to compare, for example, temperature to the concentration. Somehow we want to see how it is interconnected. So there is no way other than the equation to compare temperature into concentration. But if you want to compare the data, because data does not have any unit, it is centigrade, concentration is gram per mole, something. How you compare? Normally tendency is you compare man to man, animal to animal. You cannot compare man to animal. So we have to convert them into dimensionless form so that easy feasibility can be. So many times we convert them into dimensionless form. For example, temperature divided by temperature. For example, 100 degrees centigrade is some data. Room temperature is 30, that is steady state. So we divide 100 by 30. Now it is no more temperature because unit is cancel out. Temperature. Now it is 100 divided by 30, that is data. So sometime model predict data because in model we do not input the unit normally. We put some mathematical numbers. So first we have to convert them actually. Yes. That's why I said it is not so simple as it look like. Whenever you try to go there, you assume a lot of hours, and many months even. Many months I have to analyze this one and try to find out something, and still many times we got failed, so we try again. So we have to translate them and see. That's why I said initially in many years you will be in this loop, no, and you have to find out. And up to then, loss will continue. That is funny part. Because you are not able to solve it. As the time passes, pressure will come on you and you have to find out some things that should be relaxed them actually somehow.
Which we are getting from the mathematical modeling,
Yeah.
will be dimensionless.
Sometime dimensionless, sometime with dimensions. For example, if we do coding in MATLAB and C++, you can mention them. What is the unit that? For example, if you are doing something in Aspen Plus, there is some feature we can get. But whenever we plot something against something, we have to convert them. If we try to solve them, for everything, do not try to go for coding because it is a pain process. It's not so easy job. It's not so easy job. So initially, what we do, we drew by hand some little bit calculation. Either we use Excel or MATLAB and try to find out it is real on our part or it is from the production side. So for analysis, that's one. You should be very efficient to solve them, and you can initially guess approximately due to this one. In that case, whenever you try to solve calculation by hand, then we convert into dimensionless form. So we get some rough idea actually from where we should start. For example, if you want to compare, as I told, concentration to temperature, then you have to convert them into dimensionless form. Other than this one, for example, if you have a long reactor, a long reactor means 12 feet or in term of meter, you can assume 10 meter. So you want to check along the reactor length how the concentration is varying. It may be possible that concentration will like this one, and this is x-axis, this is y-axis, and it is not touching x-axis. So how long will you run your model? Infinity time. Your management will not be allowed that one. They ask you to solve it in 1 hour and come back to our office. So what you convert them? You convert that length, whatever it may be, 20 meter, into some dimensionless form. That dimensionless form, if you divide any length divided by total length, it will be less than 1. It means that it will quickly solve. And once you get something, if it is not touching, it means that up to the reactor outer axis, it will not a problem. You find out so essentially. That's why dimensionless is a very important part. Any other questions?
As you are saying that the solution which we are getting from the mathematical modeling
Yes.
may be dimensionless, may be dimensional. So for making the comparisons, is there any particular tool?
No, as such, there is no ready-made available. You have to do a lot of hard work because you first convert data into dimensionless. Software will not do anything. Whatever you put there, it will throw out some data. If garbage in, garbage out. You should be refine data so that output should be as expected as you are thinking. Model will not help that one. It is a mathematical number, plus, minus. You have to analyze key. Concentration cannot be negative. So if it is showing negative, it means that something is wrong. However, inbuilt, it has a principle. Principle cannot be wrong. For a heat transfer by conduction, convection, and radiation, we know that. It cannot be wrong, but data may be wrong. The implication or condition you are applying that particular model, that may be wrong. These are just for understanding what we normally. So normally before starting any work, it is our day-to-day ask we try to ask ourselves ki what is the objective actually, what we try to find out actually. The objective is a must. Once objective is finalized, for example, objective is maybe any, for example, you want to check the performance of any unit. That is your objective. A performance is a broad word. What in performance either you want to understand ki how much energy it is consuming, or how much amount it is consuming, how much chemical it is consuming, and how overall efficiency of this process. Because without that we cannot know ki what is going to come and it is profitable or not. Because this is the initial part. If something is not profitable, it will not run long. It will decay down as per the time. Right now, all of our faculty members, have you already seen many branches are no more here? For example, chemical engineering. I belong to chemical engineering. Hardly in UP and Rajasthan, even Punjab. And today I talked in the morning to the Bangalore person, and he said the same, that there is no more chemical engineering even in Bangalore. Can you imagine? If something is not profitable, or up to certain length is not profitable, it will eliminate. Similarly, business, if something is not fruitful, it will not saving cost, it will not survive. It will decay down with the time, and that is the truth. Similarly, partial differential equation, I will tell, and all required fundamentals, equipment sizing, geometry, reaction rate, and thermodynamic relations. I will not bore them all by analyzing this one. These are some terminology. Whenever we say something about model, you should aware, if somebody says state variable, some say state equation, how it look like? It look like in the form of ordinary differential equation. This is the dependent parameter that depend upon time, either concentration, temperature, pressure, something, and this size is some input, and this input influence this output, and result will after solving this one. So this is maybe linear or non-linear. Reality problem is always non-linear. असल जिंदगी हमेशा टफ होता है ना? Dreams are always fruitful, जो आप देखते हैं, it's very easy, but real life is tough. It means that real problem is always non-linear. Again, sometimes we say lumped parameter or distributed parameters. It is more mathematical kind of thing. When something we assume within something, parameters are not changing except inlet and outlet, that we call a lumped parameters. If something is going on inside, it is changing, then we call it a distributed parameter. And real time, mostly problems are distributed parameter mode. That is the toughest one. And these equations are normally, in engineering terminology, we say few words, for example, macro, micro, and molecular level. So sometime we should know ki up to what level my role is. I cannot analyze everything at molecular level because it is not a domain of engineer. Because it's not a part of curriculum of even chemical engineer to go to the molecular level. So we normally restricted to the macro and sometimes shell or differentials element level. And however, as I told, the real-time problem is always distributed. Now, if we talk about mathematical model, for example, if it is a lumped parameter kind of thing, dependent variable has only one variable. That's why have you seen many ordinary differential equation in textbook of your kids or in your even books. They are normally first order differential equation. They may be 1, 2, 100, maybe thousands equation there that depend upon how many number of variables, and assume there are more than 50 and 100 number of variables in real time system. So you know it's very difficult sometimes to imagine ki which variable is for what. So we have to mark them with number 1, 2, 3, 4, 5, 6, that is called indexing, so that we can, if somebody asks ki x12, so we have to first check what's the mean of x12, because we cannot memorize all. It's very difficult. Similarly, whenever we have more than one variables, definitely we have always more than one variable, then distributed and partial differential equation. And that is a system basically. System means that it's not just a single equation. Multiple equation will come, make your real-time system more complex. And as I told, once we build the model, we need to verify it. Verify means that कि we believe कि everything is in order. However, it is not solvable yet, but we check कि inputs are in order or not. So basically, and again that we also seen कि it is transformed correctly to the model to which we are employing that information. However, in this theoretical wording, a lot of you have a feeling कि what's going on here, but whenever you try to build it by own, you will feel the significance of word by word, line by line of this one. I am reading all this one, it is going through in my vein and I am understanding what actually these are going to tell. So that's required little bit experience. If you have seen many things, then you are able to understand this quite easily. And model validation is also a part. It's not just like you build some mathematical equation, put in software, it will solve out. No, you have to validate them. Validate with the experimental data, which I have just shown you previously, what the graph is moving. And process where result of model are compared with your experimental data or your industrial data. And it should be matched. It should not go beyond roughly plus minus 5%. If it is, then your model is not correct. Again, you have to go and try again. So it is, they said that initially it is cost saving in time, but initially it is very frustrating job to do. Again, a lot of time for coding and all this stuff. These are generally few terms: momentum transfer, whenever something is flowing. Flowing fluid is maybe gas, liquid, solid, anything. And heat transfer is something has higher temperature than room temperature, then definitely there is some heat flow is there. Heat has three modes, as you know: conduction, convection and radiation. So you have to analyze them, which one of them is applied for your particular system. Similarly, mass transfer is important. Mass means that mass and energy is very important because it costs you. If you are running AC in this room, it costs you because it consumes a lot of electricity. In industry, you run whole plant, it has lot of control system, lot of inputs, lot of boilers, pressure sensors, and many things are there. If you are running something, that costs you. So industrially, person wants to know कि before actually doing them, we want to know कि how these are going to come. These are as per our expectation or not. Now these are different level, and as we move from here to here, complexity of any model will increase. Normally in the classroom teaching of UG or even in PG, we move from overall to shell balance. In some cases for research level, we go to differential levels. But we cannot touch molecular level because it is not come in our domain. That is normally taken care by that particular field scientist. Okay, if problem, we are the first runner from the technical side to go at the side and try to find out what's going on. If I am not able to find out something, then I try to convey that information to our R&D team. They, along with me, again try to find out. Even if we are not able to find, then all of them come together and physically visit there, stay there for many days as long as, and try to find out the actual picture of the real plant. So normally, easiest way is overall balance. That is, balance means that input, output, number of moles or kg, or in term of volume. When we go a little bit inside, then we come to shell balance. It means that we take some part of geometry of that particular system that we call shell. It is in the terminology that we normally represent by delta value. Delta means that some value minus this value. Final minus initial, we call it delta x. dx, that is not a differential, that is very small thick segment of that particular geometry, and we analyze it mathematically and trying to find out the solution of x. We try to do to integrate it so that we can find out x by replacing this d. And again we go downward, then molecular simulation come into the picture. That is normally done by material science persons or some chemistry persons who normally have some research area in this one. Each have his own pro and cons. For example, overall balance does not tell us what is going on inside the system. If you are using cell balance, it will tell little bit about, for example, we know the velocities inside the system, what is the temperature inside the system, what is the pressure inside the system. That's all. If we go to differential level, then we analyze that also include the geometrical influence on the modeling. And if we again go inside, so as a chemical engineer, my domain is restricted to here, from here to here. And initially from paper and pencil, I try from this one. Because we cannot every time go for the simulation. Simulation is the toughest job. So initially we try to solve it by hand and try to guess it. It is roughly not or not. So many times we are able to find out this one. But we do not normally go to this. If we are not able to find, then we directly go to this one, differential. Because we know that once we are not able to find this one, problem will not be simple, it is more deeper. So again, if you go this one, it is strong chance to use the other. It is again a lot of work. So we switch from here to here directly. As I tell, engineering applications with the bulk properties and macroscopic behavior of the. In general, when we say something regarding to objective, I said initially we know the objective of modeling. So normally we ask two things: how this particular is taking place and why it is happening. Because how it is happening, and if it is combined, why it is coming down. So we have to analyze initially phase data, that is overall, and try to find out either in momentum, heat and mass transfer. And if something is, for example, in momentum transfer, if something is something is moving. Why something is moving? If it is not a chemical reaction or it is, if concentration is not in, there is some driving force. The cause which is responsible for to move that particular. Because you know why we normally do the job, because driving force is salary. Cell is a driving force. And if your work is passion, then again that is additional driving force towards your work. Everything is something happening that has regarding to driving force. This is again degree of freedom, that is very important part, and if you try to study this part in a book, by many books, it will very confusing, because nobody has straight mention this analysis. Degree of freedom means that what we can do, what we cannot do, just kind of thing. When we try to build a mathematical model, we try to find out कि what we are going to do, it is solvable or not solvable. अब ऐसा नहीं है कि you can say to management कि साहब we are trying to goal set and you taking many months. No, they ask you first 2 degree of analysis study करके. So you can conclude कि this problem may be correct or may not be correct. If may not be correct, then what other information do you need to make it correct? So degree of freedom is a very important analysis, and this part is missing in many textbooks of fundamental of chemical engineering. Either they are teaching for modeling, control or something. What is basically it meaning that how many equations and number of variables we need. Are you getting not bored? I hope so. Okay. If you have some question, you can ask me. You can interrupt me in between. No problem. I am a regular speaker because earlier 12 years before joining industry, I was head of department of Meerut Institute of Engineering Technology in chemical engineering department, and then I switched to Jaipur National University. I was there as a faculty part. I know very well from 12 years, and luckily I got selected to this organization, Japan Gas Corporation organization. But job task is not so easy and it require a lot of energy and attentions. Try to solve this, but this part is basically, as being a chemical engineer, it is in our domain, so it's not a problem. So when we try to solve something, somebody asks you how many equations. If you want to go somewhere, parents will ask you, and you should ask yourself how many rupees do you have in your pocket, or whatever you in pocket you go to Masuri. No, you see what your pocket allow or not. So similarly, whenever you go to modeling, you cannot jump on the modeling, open software and try to solve. No, you first analyze everything. What is your objective? What information do you have? What is missing? And these are the words, and how to calculate them. So these are the mathematical methods. They will provide you answer how many equations do you need. And things are solvable or not. If something is not solvable, why are you wasting your energy and time? The management will ask you, if something is insoluble, then why are you putting so much energy and many days on this work. So degree of freedom is very important. So I will demonstrate it by simple example, but before that, this is some algebraic formula, that is how many unknowns we have, how many independent reactions if we have, how many materials balance equation or different equation we have, how many relations we have. And by subtracting all this one, if something is good, then that should be 0. If this is not 0, then it is a problem. So before try to solve something, we try to find out degree of freedom. If it is 0, then system is completely defined. It means that you have all the information that required to run that model. And you get unique solution. Unique means that is every time you run it, you will get the same answer. Then it is okay. Because if somebody else in place of you run that model, it should become the same. But if degree of freedom is less than, what's the mean of that? It means that your unknown part is much more. It means that you have made less number of equation. It means that your system is overdefined. How? If this side is upper, this side is lower. This is negative side, less than 0. If negative side is lower, positive side is upper, then this will come into the picture. So that's why we define underdefined or overdefined. Underdefined means that you need more equation. More, but equation should be independent. Mostly textbooks just write equation. They don't know they should be independent. What the mean of independent? If we add or subtract something into some equation, you will not reproduce an equation. If you have multiple equation, by adding, subtracting, dividing, you should not be able to reproduce any equation from all them. If this is so, then equation is repeat. That is the addition of two equation. Clear? There is no blackboard, otherwise I will demonstrate it by hand. Okay, but that should not be repeatable. And how we check them? Be adding them, subtracting them, and combination of them should not be in this equation, otherwise it is repetition, nothing more. And if it is repetitions, then you will be either in this scenario or this scenario. But you should be, if you are able to solve, you again come to this one domain. So we check if there is a duplicacy in data. If this duplicacy, you have to identify it. Okay, and then try to solve it. This is some simple equation example, because all of you, any one of you have here a chemical engineer or environment engineer or something. Okay, now you will get that. Okay, for example, we are here analyzing a binary system. Binary system is that have only two components. Here for demonstration purpose I call them A and B. Small x subscript normally represent mole fraction, either mass fraction, but here this one is a mole fraction. It means that it is equal. If it is 2 liter, 1 liter is A, 1 liter is B, you mix them. Mixing is easy. If somebody asks you, please separate them, so you have to use this kind of equipment, that is called distillation. Just like we normally distill water, what you try to vaporize pure water, H2O, on the upper side, and some hardness or something will be deposited at the other. So that is purified. But how? By providing heating. So in the similar way, we normally do this one. And when we try to provide heating, this notation is for plates or trays normally. And this is look like cylindrical. Okay? And this is stream number. It is again a modeling representation. If you write something in the form of paper or in form of chart, you should be very strict to the nomenclature. So normally this rectangular blocks is represent stream number 1, 2, 3. However, here equipment nomenclature is missing. Normally it is circle. If you write here, it is a circle 1. If for example in this chart there are more than 50 equipment, so how you will analyze them? Stream number 1, stream number 2, equipment number 1, equipment number 2, there are many equipments. So normally we adhere to the nomenclature, so that equipment nomenclature is come in a circle like this one, and we put a number 1. So if circle, that is equipment. If rectangular box, that is stream. So this is stream number 1. This is 2 and 3 and many more. For here demonstration purpose, I just say. Here you can see, because this amount is coming from somewhere and it has this one composition. After distillation, you will, for example, able to measure the top, ki 200 mole per hour you are getting along with this composition. And in bottom, you see that normally we do not have this composition. Whenever you do distillation of water, you don't bother what is left in the bottom, because the coasting part is in upper side. Similarly, in the distillation, the upper side is always product. Product means that you can sell, and you measure only this one in the lab, not bottom product. But if you want to do the modeling, you should have all the data. So either you can collect them or analyze them. That is not, again, without unnecessary testing requirement, you cannot put much load on your QC, quality control department. You have to analyze them by mathematically first, and if you have some doubt, then you can go and ask them, please try to find out what the composition is there. So here the question is, before going to modeling, we analyze कि this system is soluble or not. So normally we try to find out how many equations we will try to generate. So normally, as I described previously, we have 3 domains: momentum, heat and mass. Okay. Here no data is given regarding to heat, because there is no temperature mentioned, no rate of heat flow in. It means that heat transfer is not taking place, first thing. Secondary, there is velocity and pressure data is missing. It means that you cannot build momentum transfer model. Third, mass transfer. So easily you can see there is mass can be in term of kg or in term of mole. Here it is in term of mole. It means that what you can build here, mass transfer model. Now the next question is, okay, we are able to identify it is mass transfer model. How we are going to find out it will build or soluble or not? So we have to do how many unknowns we have. 1, 2, 3. This side, if we know the total molar flow rate, if we multiply total mole into mass fraction, we know the molar flow rate of component A and molar flow rate of component D, because molar flow rate of individual component is total amount into fraction. ऐसे तो करते हैं. पिताजी की प्रॉपर्टी इज 100%, 2 भाई 50-50, 0.5 multiplied by total amount. If it is in term of rupees, you can easily calculate. Similarly here, these are 2 brothers. He has 60% weightage multiplied by 60, it has 40% weightage multiplied by 40, and if you add them, it is total, because it's mathematically, it cannot go beyond or cannot come less. Okay, so here we can see we have 3 unknown, but unfortunately we have here only 2 unknown. That's required little bit more experience, because either total amount or either any one of them, because it is a mole fractions, and fraction of anything, if n number of component, fraction of n number of component, maximum value 1. If you have 2, and once you know this one, you can get the value of this one by subtracting 1 minus this one. It means this one is, once you know this one, this is no more unknown. And once you know, either you can say these 2 known or this one unknown, either you can say this one known or this one known and this one unknown. So here you can see you have only 2 unknown. How many equation we can generate here? In term of mass transfer, we can generate here only 2 equation. First is, as I told before, overall. Overall means that we don't bother what is the structure look like. We can assume it as a rectangular block which has 1 input and 2 output. If you write a total, the total in this part and total out this. So you add them and subtract them. That is equation number 1. Secondly, out of these 2 you can generate 1 component balance equation, just like this one multiplied by this one at input, this one by this multiply this 2, and multiply this 2. So basically 2 equation here we can frame, where here we have 2 unknown, and if we subtract these 2, we will get 0. It means that this system is solvable. Clear? So by this analysis, and this is just a one equipment, there are more than 50 and 100 equipment in your sheet, because you need to do the modeling for the whole plant. There are many equipment, and by analyzing them, dividing into certain section, you pick one by one and do all this calculation and try to find out where information is missing. Now little bit more complex. If in place of 1, 2 will come into the picture. And here B for benzene, toluene, xylene. These are very important product. Benzene, toluene is also available in your chemistry lab. Here separation is find out. If something is not find out at the bottom, is again go to the second condenser that has different number of plates. And again here you can say toluene, because you know benzene is more volatile. Then benzene has 78 boiling point. Toluene is 1110 to 1111. And xylene is little bit more heavier than, and it has 123 something boiling point. If you mix them, because all are organic solvent, they are miscible to each other, and all are colorless, so you cannot identify them just by seeing them. So you have to use such kind of equipment which separate out, not purity. Here you can see benzene is approximately more pure, little bit impurity is there. So whenever we try to produce something, we always try to find out how much purity it has. Okay, but nowadays all the things are mandatory to write on the product, but nobody going to care about all this one. If you are not aware much, so you should at least see how much composition is there. It is government regulation. Everything, even in the packet of chips, they have to mention what the ingredients are. However, it is because each one has his own recipe, and that is proprietary or license. They are not bound to actually write actual composition, but approximately they write them. They have to. Okay, so you should sometime read them. Here, this is little bit more complex. Here, I just want to show how the system become more and more complex if equipment add one by one. Here, but how we analyze them? First, we analyze this one. We call this D1. Then we call D2, and then we combinedly analyze and try to find out how many variables, equations we have. Here you can see degree of freedom in either case is not 0. It means that this given information is not sufficient to build the model. You ask them to who? To the industrial who is providing you data. Some data they have to additionally provide, some other physical properties, some other chemical properties, some other reaction rate which is going on. However, it is distillation column, there is no rate, but at least they will tell you a little bit one or more, because one information, number means how much information do you missing. So one more input if they will provide, either B, T, or X, M4, M5, you will be able to solve the system. So before actually jump into modeling simulation, you analyze by degree of freedom which is missing, because once you put in something in a model, it will show error, and it's not easy to rectify error. It will consume a lot of time, error, it will show some different kind of error. So when you try to many years, then you are able to analyze that this is not possible, this error is not possible, it is internal error due to software, this is not possible, this is again not possible, many errors, and you have to analyze them. This normally basic task we do heat transfer, energy balance, conversion, operations, distillations, designing, so and so on, this part of chemical engineering. We generally talk about modeling, so these are 3 forms we normally build mathematical model, either in term of auxiliary equation is nothing, y barabar mx. Y equal to mx is the auxiliary equation that has additional subtraction kind of thing, that is auxiliary equation. Ordinary differential equation you already know, dy by dx plus y is equal to fx. Partial differential equation that has more than one independent variable, either time, x, y, dimension. Real time is always more than one, because x, y and z direction you have to study. So 3D is real model, and which is not easy to solve either by coding or by hand. So we have to normally take help from some software. There are many bunch of software. I have tried many. For example, SolidWorks, Aspen, CAMCAD, MATLAB, C++, or many more.
Sir, auxiliary equations are only linear or it may be non-linear?
Who knows? Because these are not described by me. That is the requirement of the system. But real problem,
Any type.
yes, but real problem is always non-linear. It's not linear. Linear is quite easy, and nothing easy in this world. Everything is complex. For example, we will hear steady state just to show the model, and for this one, I will just show you the picture. This one is some separation unit. For example, earlier I have shown just 2 component. Here it is 3 component. Normally in a real-time system it is more than 25 component. So there are many equations. This is some input, output, bottom product again goes to here. Again we have to analyze this one. First we should study degree of freedom, and degree of freedom analysis, how many number of variables we have, and if it is 0 then we move ahead to make equation and try to solve them. But when we try to solve large model, we try to build normally that equation, we convert that equation into some matrix form. And you know, from 10+2 or engineering level matrix is look like this one. This is rows and column, determinant. This is order of sign, plus, minus, minus. It is nothing, just addition of this one. 1 plus 1, even number. If it is negative, minus 1 square positive. This is again odd number, minus 1 ki power odd is odd. Like this one they follow. How many rows, and that is called size of the matrix normally. That is go up to 100 into 100. 100 element like this one, 100 element like this one. And whenever you have more than 100 element, it is very headache to identify each one of them and which one is causing problem for you. So this is some simple mathematics you already know. This method is normally I adopted whenever we have less than 20 molecules, or we normally do not go for 10 to 15. If we have element, we don't go for simulation. We try to solve it by hand, because simulation running consume a lot of time, because you have to sit there, you have to analyze the data. First you have to just say which is going on. So by hand you can easily judge them if you know little bit mathematics. So we can find out the inverse of matrix. This is again the second method, Cramer's rules we also follow, but determinant part should not be 0, that only it work, because if it is 0 then it will convert into infinitive. It means that this method will fail. And this is Gauss elimination method. This is for such kind of method is normally we applied for UG or PG project, because we cannot allow student to solely based upon software tool, because you should first know the basic fundamental of the mathematical modeling and show them by hand calculation what is going to come if you are going for the computer simulations. So first you know the basic. That's why we prefer to project a student to demonstrate it by hand first. And little bit, these are some other Gauss-Jordan method. Each have some additional advantage, disadvantage. And if you apply all this method to like this one, here it is nothing, just total input is equal to total output. This one is input from, if you remember from the earlier figure, if we see this is input, this is output. This is not output. This is output only for this one. But if you see overall picture, we construct a block diagram by this one. So this arrow is going out, this arrow is going out, this arrow is going out, this arrow is going out. And we are considering rest of the block. That's why we call it overall modeling. We don't bother what is going on inside. Earlier, if you remember, I have shown the overall, then shell, then differential, and then molecular, different level of engine. So if you do the overall, that is first easiest step. So here F1 is input, F2 out, F4 out, F5 out. And we substitute the amount here. F1 is 10, we write this is first equation. Similarly, for component balance is nothing, just multiply that fraction into total amount that is coming along, and we add them. And whenever we have many number of equation, we convert them into some matrix form. If you are not comfortable with the matrix form, you can keep it in this equation form. But matrix form is a more compact form in a visualization form. Now after this one, if maybe it is more, no problem. Then from this you can know you need to find out only this one. What you do, this is AX is equal to B. So X inverse, just like this is A, this is X, and this part is B. And from this, X is basically unknown. So if you find out the X, this will come here, and we call it in terminology of matrix A inverse. And an A inverse, this is nothing, 1 upon determinant adjustment A. And we try to solve it that by hand, and the student will grasp what is going to come. And once they are strong enough to do it by hand, then we allow them to do by simulation. If simulation shows some error, their back thinking know what's going to come, and if it is no it come, where the problem will be. Because this knowledge will help you whenever you encounter some problem in simulations. However, with the help of MATLAB, it is just a one-line command. You write like this one, 1 1 1 semicolon, next line 1 1 semicolon, next line like this one. You write B, this, and you write X A backslash B. It will solve you. You will get this one. So by mathematical tool, it hardly take less than 1 millisecond, but by hand, it is consumed a lot of energy. But that is the essential part for understanding purpose, so that later an error will come. You can easily grasp what is the basic fault in the model. Similarly, I will try to little bit touch, not many, but little bit. Actual distributed systems are that has more than one variable, X, Y, Z, T. And normally we encounter this kind of phenomena, mass transfer, momentum and energy. And when we talk about a transfer, then we also talk about in what coordinate. So normally in mathematics there are 3 coordinates, that is Cartesian coordinates and cylindrical coordinates and spherical coordinate. If something is spherical or cylindrical, we take the benefit of the geometry to simplify the mathematical model if we do by hand. But if something is due by coding, then we don't bother, we go for Cartesian coordinate system. Cartesian coordinate is not just X, Y, Z. Okay. Everything in reality is 3D, like this room. This room has this and this. Everything has length, width and dimensional. The real system is always 3D. Sometimes one part is not as dominated as other, then we somehow up to certain level we can neglect them, but not fully. Because once you sacrifice one property of any system, it has some disadvantage in other side as well. So again, whenever you made assumptions to make modeling, you should be aware of that. This is basically fundamental. Okay, if we go for differential dx for any system, either solid, liquid or gas, this chamber, it looks like chamber, it is small segment of any, either maybe for this room or for maybe inside this room, this air, you can consider this one. And we can develop the equation for this one. We can apply this one to this, everything, because at a small scale, you consider small segment, apply forces. What forces we have? So normally in industrial scale as a chemical engineer, we talk about momentum, mass and heat transfer. And from this side, mass is coming, this side is going. It is called x direction. Perpendicular to this board, it is y direction, and this one is z direction. So here, this is mass movement. Density is nothing, just a mass. It has unit kg per meter cube, because we are talking about unit volume. That's why we convert m into rho. In and out, you multiply by area, because later on you convert them into some differential equation, and differential equation, nothing, it is an equation. When you try to solve it, you do the integration, and integration is applied on the geometry. Then that's why you have to consider the geometry, from where to where it is moving and how it is influencing. And if you do so, you kind of like this one, accumulation of mass divided by x, y, z, and you will get this kind of, this is partial differential equation. Normally it is not a d, it is a little bit curly. It is d, time domain, d, x domain, d, y domain. It means that this property which is inside this one depend more than one variable, x, y, z, t, and many more number of variables. So similarly, we can develop a continuity equation like this one. It is very basic, fundamental, available in the book. Similarly, for molar, if you come to the picture, normally when we say something is flowing, there are two kind of motion normally, convective motion and diffusional motion. Convecting motion, what is convective motion? You are, अभी आप लोग भीड़ में जा रहा है तो धक्का आपको पीछे से मिला, वो कन्वेक्टिव है. You are moving by your own leg, वो diffusive है. तो जब आप भीड़ में, whenever you move in a bulk, you both have convective and individual movement. धक्के से भी आप मेट्रो के अंदर जा रहा है, खुद भी चल के जा रहा है. तो combined, that is normally trapped by this equation. And you can put your weight here, your velocity, you will calculate how long will we go there. It is applicable to everywhere. And similarly, if you again put this value into this, elaborate and separate out, you will get this kind of equation. And however, it look lengthy equation and horrible, but component wise, this is convective terms because it is related to x, y, and z movement. This is time accumulation of that particular, and this is diffusional. And this is if some reaction is going on. So this is one kind of equation for one component. If there are more than one component, maybe 10, 12, you can write a similar equation. And you can see it's not easy to solve by hand. So whenever we go for complex system, it is advisable to use some coding either in MATLAB, C+, or something. And I think I have not shown you how many software we have. This is different software. However, this is related to not all branches, but I work Excel, you always aware, it is also very Polymer, Scilab. These are open tool. This is again free, but this is very good tool. That's why I put it here. I worked a lot in MATLAB, and it is feasible up to certain extent. But for huge plant, you cannot go for MATLAB because it takes many months to build the model, and they don't provide us enough time. They say it come tomorrow along with all your results. So it's not so easy to go for all this one. And this is process simulation regarding to chemical engineering. Aspen Plus is one of the favorite. Why it is favorite? Because it has huge inbuilt library. Inbuilt library, all research data that is available in public domain is inside this one. So you need not to type anything, everything is available along with the supporting document. Aspen HYSYS is little bit more equipment sizing. If you want to study whole plant, then Aspen Plus is good. If you want to select some particular equipment, you want to study that Aspen HYSYS is good. Similarly, replica of ChemCAD. ChemCAD is very easy and user friendly. Unisem is also very good, just like to similar Aspen Plus. Pro is also, I used Pro, but all are paid software. Similarly, in AutoCAD, SolidWorks, I also works in SolidWorks. That is more related to the mechanical engineering, but to build some geometry, you need to this one, and it simulate also, and something. And similarly here, I want to show you, yes, ANSYS Flute. If you want to study something that is flowing inside any geometry, then that is very good software. But that required a lot of huge computer control system to run. Actually, a computer should have at least 20 GB RAM. These laptops are hardly 4 GB RAM or 6 GB RAM, it will not work. So they required very strong hardware, or if you don't have, then you have to transfer that data on the cloud computing. For example, in our case, we don't have here in India for the company to which I am working. I normally transfer the data on the cloud computing. The data will go to Japan. They have huge server. They calculate it. Data again upload on server, come back to me. And then it will take 2 and 3 days time, come back to me, and I'll upload the data. And this way, they transfer data, because everywhere you cannot build supercomputer lab, it is very costly. So normally we do by transferring on the cloud computing data. And by, you know, how the Mat look like. The other part is of MATLAB I like most, it has very strong documentation. What does mean that if you have something problem, you cannot go ask everybody. Nobody is available there. You can go there, type here, it is inbuilt feature, or it is also available online features. If you click here, it will connect online and try to find out the solution there. But because MATLAB has approximately started from 1984 and onward, so it has very good literature. It means that everything you are seeking, try to solve your problem will be, I believe, would be available here. In my PhD, I did a lot of work in real-time control system by controlling small plant by my laptop. Not this one that has again the same GB RAM, but it was very tricky part and very tough job. That's why it took near about 6 years to complete. But somehow I am able to manage. Okay, this you already know how to write a code like this one. You will get the final solutions. Similarly for bubble points calculation, code is like just like you writing something in your paper and you convert into code by something. This part is, these lines are look little bit lengthy, but this is fancy part. This is what is being written, x1, p1, this is equation, this is one function, we calling this function into here, with this one, it will solve you in one. You can avoid this one because these are just x-axis and y-axis name display or something. Similarly for batch distillation, many things, you convert them, write them, what part you need to, how to select initial conditions. This is again a simple distillation look like, and many things. And thank you very much. If you have any questions, you can ask me.
Is there any questions?
पूछिए आप, जरूरी नहीं है इससे पूछें, because I was bound to, because my topic is related to process modeling and control. However, other than this one, there is a lot of area. If somebody has some questions regarding to industry or something, I am happy to answer. Don't hesitate to ask. I am just your colleague, your big brother or younger brother, you can assume. You can ask me if anything you assume. Any questions? Or something else you want to ask? You can ask, no problem.
Thank you, sir. What a truly insightful and a thought-provoking sessions ahead. On the behalf of the entire organizing team of this activity, I take immense pleasure in inviting Dr. Sunil Rojaria, co-coordinator at Vivi, to present a small token of thanks to our esteemed speaker as a gesture of gratitude and appreciation for their valuable time, efforts and wisdom shared with us. Thank you, sir, for the enlightening sessions.
Thank you all for listening for your time.
Now we move to a short but engaging segment, our article discussion session, where we delve into the world of academic research. Today's article is entitled Embracing the Future of Artificial Intelligence in the Classroom, the Relevance of AI, Literacy, Prompt Engineering and Critical Thinking in Modern Education, published in the International Journal of Education Technology in Higher Education in 2024. Today's format is a little bit different from the yesterday's sessions, so if you have any query related to that, then kindly ask. We will provide you the article sessions. Kindly be seated with your teams. so that you can write down the key findings for your articles. Welcome back everyone. We now begin our afternoon session by our renowned academician, Dr. Pradeep Kumar, Associate Professor from IIT BHU. May I now request Professor Dr. Sunil Rajoria sir to kindly come forward and present the Vastram and sapling as a gesture that symbolizes honor and appreciation to our session speaker. Please sir. Dr. Pradeep Kumar is an Associate Professor in the Department of Chemical Engineering and Technology, IIT BHU Varanasi. He holds a BTech in Chemical Engineering from Amravati University and MTech from the IIT Roorkee and a PhD from IIT Roorkee. He further enriched his academic experience as a postdoctoral fellow at University Sains Malaysia from September 2009 to 2010. His research interests span a broad range of environment and chemical engineering domains, including industrial pollution, abatements, catalysis, thermal treatment, coagulation, flocculations and absorption, biomedications, pyrolysis and solid waste management. Dr. Kumar has contributed significantly to sustainable development technologies through his academic and research engagements. Thank you, sir. He will enlighten us on the topic Emerging Technologies for Wastewater Treatment, a subject that plays a vital role in the environmental sustainability and urban infrastructure. Please join me to welcome Dr. Pradeep Kumar sir with a big round of applause. Please sir.
To the organizers who called me for this lecture. Basically, I use both languages, Hindi and English. I hope you can easily understand. And whatever ma'am has told me about this, you can see I have gathered a lot of informations, or we start slowly and get that much amount of work. So if you start, then you definitely will get the success. So in wastewater treatment, I hope everybody have listened one share.
विसाले यार से दूना हुआ इश्क, मर्ज बढ़ता रहा जो दवा की. तो सेम चीज़ जो है हैपनिंग इन वेस्ट वाटर ट्रीटमेंट. व्हाट वी हैव इनिशिएटिव कहाँ से शुरू किया? कोगुलेशन, फ्लोकुलेशन. हम क्या पढ़े? दो तरह का होता है, एक हार्डनिंग, हार्ड वाटर, सॉफ्ट वाटर, राइट. वहाँ से हम लोग शुरू किए जर्नी को. आज हम कहाँ गए? माइक्रोप्लास्टिक्स, माइक्रोन्यूट्रिएंट्स, माइक्रो वो. और हो क्या रहा है? व्हाट वी आर गेटिंग? रिजल्ट्स? नथिंग. फर्स्ट वी हैव स्टार्ट प्राइमरी ट्रीटमेंट, देन secondary treatment, then tertiary treatment. Now comes to the advanced treatment and combination of process. Combination. But still we are not getting fresh water. Reason? Our requirement, right? Our consumption, human population, industrialization, all these factors. At what we have only 1% fresh water. Rest we are having sea water or polluted water. Industrializations in initial stage, if you see, our requirement is very less, है ना. अगर आपने देखा हो तो पहले एक थान के कपड़े में से पूरे घर के कपड़े बन जाते थे और वो किसी को प्रॉब्लम नहीं होती थी. आज हर किसी की अलग अलग अलमारी है और उसके बाद भी कपड़े नहीं हैं. तो क्या हो रहा है? हमारा कंजम्पशन इंक्रीज हो रहा है, डिमांड इंक्रीज हो रही है. और डिमांड को पूरा करने के लिए हम क्या कर रहे हैं? इंडस्ट्रियलाइजेशन को इंक्रीज कर रहे हैं. ये करिए, है ना. पहले नलके का पानी पी के आपका किसी का पेट खराब नहीं होता था, राइट? आज आप पी के दिखाइए, आज सबको बिस्लरी चाहिए, और हम जानते हैं कि 1 लीटर बनाने में 3 लीटर हम वेस्ट करते हैं, 3 to 4 लीटर्स हम वेस्ट करते हैं। तो हम क्या कॉस्ट पे कर रहे हैं? ये जो है, ये सबसे बड़ा प्रॉब्लम है हमारे डेवलपमेंट का। तो इससे क्या हो रहा है, हमारा जो टाइप ऑफ पोल्यूटेंट हैं वो इंक्रीज हो रहे हैं, है ना? क्योंकि हम डिफरेंट टाइप की इंडस्ट्री यूज़ कर रहे हैं, डिफरेंट टाइप के मेटरोलॉजिकल मटेरियल प्रोसेस यूज़ कर रहे हैं, जिससे हम डिफरेंट टाइप के केमिकल्स को जो हैं वो एक्सट्रैक्ट कर रहे हैं, माइनिंग कर रहे हैं, तो वहाँ से भी हैवी मेटल्स निकल रहा है। वो कहाँ जा रहा है? अंडरग्राउंड वाटर में, लीचेज। वो अंडरग्राउंड वाटर कहाँ आ रहा है? देन अगेन आपके ड्रिंकिंग वाटर में। ठीक है, मोस्ट ऑफ द इंडस्ट्री क्या कर रही है? अनट्रीटेड वेस्ट को वो या तो रिवर में छोड़ रही है, पॉन्ड में छोड़ रही है, लेक में छोड़ रही है, अनट्रीटेड वेस्ट को। एंड वी हैव मेक लॉट ऑफ, you can say, rule and regulations. We have pollution control board, we have central pollution control board, we have different type of authorities who are working in this for your welfare or to control the pollution. But result, you see, आप कहीं चले जाइए, आपको पानी के अंदर पॉलीथीन मिलेगा ही मिलेगा, आपको वेस्ट मिलेगा ही मिलेगा। जहाँ ह्यूमन है, समझ रहे हैं ना, वहाँ वेस्ट है। जहाँ एनिमल है वहाँ वेस्ट नहीं है, जहाँ एनिमल है वहाँ वेस्ट नहीं मिलेगा, लेकिन जहाँ ह्यूमन है वहाँ आपको वेस्ट मिलेगा। आज मॉर्निंग में मैं पढ़ रहा था, हिमालय में लगभग 200 बॉडीज़ आज भी पड़ी हुई हैं, डेड बॉडीज़। जो लोग हिमालय चढ़ते हैं ना, उनकी लगभग 200 लोगों की बॉडीज़ आज भी पड़ी हुई है, जिसको हिमालय से निकाला ही नहीं गया, पड़ी हुई है एज इट इज़। हम अपने जो एनवायरनमेंट को है बेसिकली वो पूरी तरह से हमने क्या कर दिया? पॉल्यूट कर दिया। कहाँ है चलाने वाला? सो दिस टाइप ऑफ स्टोरी आप बहुत जगह पढ़ते हैं। ऐसा नहीं कि बहुत सारे एनजीओज भी काम कर रहे हैं, बहुत सारे लोग काम करते हैं, बट स्टिल हमारी जो पॉपुलेशन ग्रोथ है, थिंक अबाउट इट, पॉपुलेशन ग्रोथ वो जो है ना, वो इतना अधिक है कि हम उसका लोड नहीं सहन कर पाएंगे। थोड़े दिनों में आप देखिएगा क्या हाल होने वाला है। और मैम वो होगा ना कुछ? अच्छा, इसको अप करना है? ओके, राइट। सो ये फर्स्ट स्लाइड यू कैन इजीली अंडरस्टैंड विच आई हैव टोल्ड यू। हर जगह का वेस्ट, whether it is industrial discharge, whether it is plastic waste, whether it is right. So agriculture and everything. Now you can see, so the economic development only, agriculture, industry and energy production. So these are the basically मेन दोज हु आर कंट्रीब्यूटिंग टू द पोल्यूटेंट। हम कहते हैं कि पोल्यूटेंट, बट वी स्टार्ट फ्रॉम आवर ओन हाउस, राइट? वहीं से शुरू हो जाता। सो एंड यू कैन सी द वर्ल्ड वाइड फ्रेश वाटर इज प्रोजेक्टेड टू हैव एन इंक्रीज ट्वाइस क्विकली एज द ह्यूमन पॉपुलेशन। In 2050, consumption is predicted to be tremendously high than it's today, and with over 40% of world population facing water problem. है ही नहीं, पानी नहीं है ना? साउथ अफ्रीका का आपने पढ़ा होगा, एक सिटी का पूरा स्टडी हुआ था, है ना? नाम भूल रहा हूँ, बट आएगा, रिकॉल आएगा तो मैं आपको बताऊँगा, जहाँ पे पानी नहीं है, पानी ख़त्म हो गया, ड्रिंकिंग वाटर ही नहीं है, नॉट इवन सरफेस, नॉट इवन ग्राउंड, ऑल फिनिश्ड, ख़त्म हो गया, क्योंकि हेयर वी हैव गुड सोर्स ऑफ वाटर, सो वी आर नॉट थिंकिंग कि हाउ वी कैन यूज़ इट, कैसे यूज़ करना है ना। तो ये जो प्रॉब्लम है ये इंक्रीज होने वाली है आपको, ठीक है। सो नाउ व्हाट इज़ द मेन currently is cost effective. Cost is another. आप कोई भी ट्रीटमेंट मेथड यूज़ कीजिए जो एडवांस मेम्ब्रेन यूज़ करिए। आपके यहाँ जितने, सबके यहाँ आरओ लगा हुआ है ना, सबके यहाँ लगा है ना। आप हर 3 महीने में आरओ में 5 से 7 हज़ार रुपये, 10 हज़ार रुपये इन्वेस्ट करते हैं, है ना, कि आज उसका मेम्ब्रेन फ़िल्टर ख़राब हो गया, आज उसका यूवी ख़राब हो गया, आज उसका ये ख़राब हो गया। ये तो तब है व्हेन यू आर यूजिंग इन योर होम वेयर कंजम्पशन इज़ वेरी लेस। नाउ इमेजिन एनी डिस्टिलरी, एनी शुगर इंडस्ट्री, एनी लेदर इंडस्ट्री, राइट, एनी अदर बिग इंडस्ट्री, हाउ मच वाटर दे आर यूज इन टेक्सटाइल इंडस्ट्री, कितना यूज़ करते होंगे। देन फॉर ऑल दिस पर्पस कितना पैसा इन्वेस्ट करते हैं, कॉस्ट कहाँ जाती है। सो इट शुड बी कॉस्ट इफेक्टिव, राइट, है ना। हम कोई भी काम वो नहीं करते जो कॉस्ट इफेक्टिव ना हो। कॉस्ट इफेक्टिव, एफिशिएंट, comprehensive techniques to improve the existing method for some initiatives। तो वही मैंने आपको बताया कि सब जो है वो हम क्या कर रहे हैं, कंबाइन कर रहे हैं। तो जब प्रोसेस कंबाइंड हो जाएंगे तो नेचुरल सी बात है आपकी जो कॉस्ट ऑफ इन्वेस्टमेंट है वो ऑटोमेटिकली इंक्रीज कर जाएगी, ठीक। और हर इंडस्ट्री का या हर चीज़ का सैलरी से ज़्यादा पैसा नहीं खर्च कर सकते ना, उसी में आपको बचाना भी है, उसी में आपको सब चीज़ पूरी करनी है। तो उसका एक सर्कल है आपका, तो वो कॉस्ट इफेक्टिव होना चाहिए। तब आप कहेंगे कि नहीं ये सैलरी मेरे को, आई एम हैप्पी टू वर्क इन सुभारती इंस्टीट्यूट बिकॉज द सैलरी आई एम गेटिंग, आई एम इजी, वेरी, है ना, इजीली कंप्लीटेड माई ऑल एक्सपेंसेस, मुझे कोई दिक्कत नहीं है। देन ओनली यू कैन वर्क हियर, है ना। और अगर वो नहीं पूरा पड़ेगा तो व्हाट यू आर डूइंग, यू डू सम एक्स्ट्रा एफर्ट कहीं से ताकि यू कैन अर्न मनी, मोर मनी, राइट, ओनली देन। मैडम लेक्चर के बाद मैं अपनी क्लास में नहीं अलाउ करता हूँ। आप फैकल्टी हैं तो आपको तो पता होना चाहिए, राइट। मोबाइल क्लास के बाद, जब मैं ख़त्म कर दूं उसके बाद, राइट। तो क्या करते हैं हम लोग, वी कैन एफर्ट डालते हैं टू सस्टेनेबल बेसिकली, ताकि हम सस्टेन कर सकें। मेन तो वही है ना, और तो कुछ है नहीं। हमको सस्टेन करना है, अपना प्रोसेस सस्टेन करना है, अपना प्रोडक्ट सस्टेन करना है, सो दैट वी कैन अर्न सम अमाउंट मनी, प्रॉफिट। हर इंडस्ट्री प्रॉफिट के लिए चलती है, हर इंस्टीट्यूट प्रॉफिट के लिए चलता है, राइट। तो ये जो है ये एक सबसे बड़ी प्रॉब्लम्स है हमारे प्रोसेस से। नाउ यू कैन सी दिस, हमने पहले पढ़ा फिजिकल, केमिकल एंड बायोलॉजिकल ट्रीटमेंट, हमने ऑलरेडी वी हैव अंडरस्टैंड फॉर। सो दीज आर द सम डिफरेंट टेक्निक्स विच वी आर यूजिंग इन एज एन बायो वेस्ट। नाउ द बिकॉज माइक्रोप्लास्टिक्स, माइक्रोबायोलॉजी, आपको जितना भी डिजीज़ पेट में हो रहा है या जितने भी कॉजेज़ आज ह्यूमन बॉडी में हो रहे हैं, उसका मैक्सिमम कॉज है बायो। वो क्या हो रहा है, वो किसी ना किसी थ्रू से, हमारे बैक्टीरिया के थ्रू। कोरोना क्या था, वायरस ही तो था, एक छोटा सा वायरस जिसने पूरा दुनिया आपका बंद कर दिया। बट उसका फ़ायदा क्या हुआ, आपकी नदियाँ साफ़ हो गई, आपके तालाब साफ़ हो गए, है ना, सब चीज़ें साफ़ हो गई थी 3 महीने के अंदर, 5 महीने के अंदर। जो आपका सब शटडाउन हुआ और उन्होंने कहा ये जो जानवर है इसको बंद करो घरों में, ये जानवर बंद रहेगा तो सब चीज़ें ठीक रहेंगी। और उससे हो गया था, हम सब और आप कमरे उसमें बंद थे, सब चीज़ें धीरे धीरे साफ हो गई थी ऑटोमेटिकली, बिकॉज वो नेचुरल है, वो अपने आप को ठीक करता है, नेचुरल है वो, क्योंकि वो उसी तरह के हैबिटेट्स हैं, उसी तरह के केमिकल्स रिएक्शंस होती हैं, उसी तरह का है। आप इफ़ यू सी, आप ट्रैवल करते हैं, सब लोग ट्रैवल करते हैं ना, किसी दिन किसी पुल के ऊपर बैठ खड़े होइएगा एंड देन ऑब्जर्व, जिस किनारे पे आपको वेजिटेशन ज़्यादा दिखाई देगी ना, वेजिटेशन, वहाँ पे पानी आपको एज कंपेयर टू द अदर ज़्यादा साफ सुथरा दिखाई देगा, क्योंकि वो जो वेजिटेशन है वो ऑक्सीजन इंक्रीज करता है, वो पानी को साफ करने की प्रोसेस में लगा रहता है, क्योंकि वो उसी जीवन उसी का है ना, वाटर से ही चल रहा है ना। लेकिन जो जिस किनारे पे आपको वेजिटेशन नहीं मिलेगा, वहाँ पे आपको देखिए आपको पानी भी साफ नहीं मिलेगा, वहाँ पे पोल्यूशन आपको ज़्यादा दिखाई देगा। और ये आपको किसी दिन आप यू कैन ईजिली सी फ्रॉम योर नेकेड आइज, आप आराम से देखिए, आपको महसूस होगा कि नहीं। इसीलिए जो बोलते हैं ना, पेड़ लगाओ पेड़ लगाओ पेड़ लगाओ, ये लगाओ, पेड़ बचाओ पेड़ बचाओ, वाई इट इज़ नेसेसरी। और ये एक नेचुरल प्रोसेस है जो ऑटोमेटिकली वाटर को क्लीन करता है। उसके लिए हम कोई फिल्टर थोड़ी लगा रहे हैं या माइक्रो ऑर्गेनिज्म, वो ऑलरेडी वहाँ पे हैं, वो ऑटोमेटिकली डेवलप हो रहे हैं, वो उसको क्लीन कर रहे हैं वाटर। और तो प्रोसेस है, चल रहा है, नेचुरल प्रोसेस है। तो ये जो है, ये सब डिफरेंट टाइप के प्रोसेस हैं। ये देखिए, नाउ यू कैन सी द केमिकल, फिजिकल एंड बायोलॉजिकल, then best approach pyrometeorological, electrometeorologically and hydroelectrometeorologically, biobleach. So these are all different type of process where we use higher temperature, right? Now we can say हमारा जो contaminants है water में जो है, वो इस तरह से डेवलप हो गया है, वो नेचुरल टेम्परेचर पे ख़त्म ही नहीं होता है ना। पहले क्या बोलते थे, पानी है बॉयल कर लो, छान लो, ठंडा कर लो, पी लो। अब वो बॉयल टेम्परेचर मतलब 110 डिग्री सेंटीग्रेड पर भी वो किल नहीं हो रहा। उसका क्या हुआ, नेचर जो है, सेल बदल रहे हैं, नेचर बदल रही है। तो हमको क्या चाहिए, हायर टेम्परेचर। अब हम बात करते हैं हायर टेम्परेचर, हायर प्रेशर की, है ना। तो हम डिफरेंट टाइप के प्रोसेस वो यूज़ कर रहे हैं आज पर उसके लिए, वेस्ट वाटर के लिए, जिसमें अब हायर टेम्परेचर हायर प्रेशर होगा तो नेचुरली बात है कॉस्ट डबल हो जाती है। एटमॉस्फेरिक टेम्परेचर पे काम करिए, एटमॉस्फेरिक प्रेशर पे काम करिए, कॉस्ट इज़ वेरी लेस। बस सेम thing you will do in higher temperature, higher pressure, cost will high. And then you make some catalyst, use some catalyst so that you can easily break the chain. Then only you can produce the CO2, H2O, yeah, other chemicals, right? The main is to break the chain. So we need catalyst. Again we What will happen, हम पूछते हैं सबसे, जितने भी लड़के PhD करते हैं, ठीक है आपने ट्रीट कर लिया, ट्रीट करने के बाद जिस चीज़ को मेथड से आप यूज़ कर रहे हैं उसका आपने क्या किया, सर वो तो हमने फेंक दिया, मतलब तुमने वेस्ट फिर क्रिएट कर दिया। सस्टेनेबल कहाँ से रहा। सपोज यू डू सम कोगुलेशन प्रोसेस या एडजॉर्प्शन आप कर रहे हैं, तो आपने एक एब्जॉर्बेंट बनाया, उससे पानी को ट्रीट किया, उसके बाद सवाल उठता है आपने एब्जॉर्बेंट का क्या किया। तो आपने कहा हमने तो लैंड पे फेंक दिया, यानी जो हैवी मेटल्स, जो पोल्यूटेंट आपने उसमें एब्जॉर्ब किया वो आपने लैंड पे फेंक दिया। तो उससे क्या होगा, अगेन तो वो साफ नहीं हुआ ना। आपकी थीसिस हो गई, यू गेट अ PhD डिग्री आपको मिल गई, बट पोल्यूशन तो सीख पूरा नहीं हुआ ना, तो वो सस्टेनेबल नहीं हुआ। तो आजकल ये एक अगेन प्रॉब्लम्स तो बहुत सारे बोलते हैं सर व्हाई नॉट वी यूज इन फायर, हम जला दें उसको इंसिनरेशन में, देन अगेन मेटल में कन्वर्ट हो जाएगा ऐश। तो सस्टेनेबल होना इज वेरी नेसेसरी, कि हम एक चीज को खत्म करने के लिए कहीं दूसरी चीज तो क्रिएट नहीं कर रहे हैं। और यही हो रहा है एट प्रेजेंट, यही हो रहा है। हम एक पोल्यूटेंट को खत्म करने के लिए दूसरे माइक्रो पोल्यूटेंट को जन्म दे रहे हैं। और वो क्या है, वो आइडेंटिफाई नहीं होते। बहुत माइक्रो लेवल पे जाइए तब वो आइडेंटिफाई होंगे। अरे बाप रे, ये तो ये है ना। पहले मिलीग्राम पर लीटर से अब हम पीपीएम में आ गए हैं, पार्ट्स पर मिलियन में। पोल्यूटेंट की रेंज आप देखिए, अब आप वो पीपीएम में लिखता है। पीपीएम में आ गए ना, कि ये मान लीजिए मैग्नीज है तो इतने पीपीएम होना चाहिए, 0.001। अब ये करिए डिटेक्ट, ठीक। अब वो तो डॉक्टर बताता है कि साहब ये डिजीज़ आपको इस वजह से हुआ, ये डिजीज़ आपको इस वजह से हुआ। वाटर बाउंड डिजीज़ सबसे ज़्यादा है, सबसे ज़्यादा। वजह हमारा सो दिस ये अभी हम बेसिकली वी आर ट्राइंग सो दैट वी कैन प्रोड्यूस पावर, जनरेशन कर सके किसी भी चीज़ के लिए। तो जितना भी सॉलिड वेस्ट निकल रहा है डाइजेशन के थ्रू, डाइजेस्टर के थ्रू, वी कैन कन्वर्ट इनटू मैन्योर, एंड देन मैन्योर विल कन्वर्ट इनटू आवर एनर्जी रिसोर्सेज। तो हम बेसिकली अभी एट प्रेजेंट वी आर कंसंट्रेटिंग ऑन ऑल दीज प्रोसेस, कि हमको क्या करना चाहिए। ये ऑलरेडी क्लैरिफायर है, एरिएशन है, ग्रिट रिमूवल है, फर्स्ट वो है आपका। तो ये सब करके हम लोग वी आर यूजिंग। सो अभी कितना जनरेट कर रहे हैं, नाउ यू कैन सी द वाटर पोल्यूशन जनरेट 38354 MLD सीवेज जनरेट इन द बिग सिटीज। हाँ बताओ। हाँ नहीं, मैन्योर नहीं बनाते उसको रिसाइकिल करते हैं। हाँ, टोटल रिसाइकिल करते हैं अगेन। इसीलिए आप देखिए बायोप्लास्टिक आ गया, जो बायोडिग्रेडेबल है, आपको यूज़ कर लेते हैं, ठीक है। अब हमारे यहाँ क्या है, पॉपुलेशन इतनी ज़्यादा है, ठीक है। जब मैं मलेशिया में था तो हमको एक बैग मिलता था, हम किसी भी अगर उसमें जाएं, टेल्को का एक टेस्को का एक बैग मिलता था। वो इतना मजबूत था और वो बायोप्लास्टिक था। अगर वो फट जाए तो आप जाइए, उस बैग को वापस करिए, उसकी जगह एक नया बैग ले आइए, इस्तेमाल करिए, है ना। आपको तो शायद पता नहीं, लेकिन मैं अपने बचपन में जब कुछ भी लाता था तो कागज़ के बैग में लाता था, चाहे वो चीनी हो, दाल हो, शक्कर हो, हैं, और कपड़े का बैग लेके जाता था। नहीं, अब लेके जाते हो तो इसलिए कि सरकार तुम्हें कह रही है मत लेके जाओ। नहीं तो पहले क्या होता था, अच्छा सामान लाना है, चलो ला भाई, ये तोल दे, ये तोल दे, ये तोल दे। उसने फटाफट आपको पन्नी में दी और आप 10 पन्नी लेके चले आए घर, ये लीजिए। फिर मम्मी क्या कर रही हैं, उसमें कचरा भर रही हैं, उसे फेंक रही हैं। यही कर रही है ना, यही कर रही हैं। फिर वो वापस भेज फेंक रही हैं, है ना। नहीं फेंक रही, क्या करती हैं, ये देख, मतलब रिसाइकिल हो रहा है ना, रीयूज हो रहा है ना भाई। वहां से लाई, ननद को दे दिया तो भाभी बहुत अच्छी है, मैं बताइए मेरे को प्लास्टिक दे रही है। तो ये सब चीजें जो हैं हमको रिसाइकिल करनी। प्लास्टिक को आप उसमें डाल ही नहीं सकते। आप 100 साल बाद भी अगर खोदेंगे तो जूका तो निकलेगा, वही निकलेगा। और क्या होता है, बगल में कोई प्लॉट खाली है ना, उसमें देख कितना कचरा है, प्लास्टिक नहीं है तो साफ करा देते हो, बट लेकिन हर 6 महीने में भर जाता है ना प्लास्टिक से, फिर उसको, लेकिन वो साफ कराने के बाद वो कहाँ जा रहा है। मेन हमारे यहाँ प्रॉब्लम क्या है पता है, क्यों हम लोग साफ नहीं हो पा रहे या क्लीनिंग क्यों नहीं है प्रॉपर? क्योंकि हमारे यहाँ एक तो प्रॉपर कलेक्शन सिस्टम नहीं है, सेग्रीगेशन नहीं है एट होम, ठीक है। अमेरिका में, यूके में ना इतने डॉलर का फटका पड़ता है ना कि आदमी एक चीज गीला सूखे में नहीं डालता, सूखा गीले में नहीं डालता। अब तुम कहोगी सर वो कैसे पता चलता? वो जो आता है ना गाड़ी लेके, वो उसको सब रहा वो ठुकवा देता है, मार दीजिए फाइन इतने डॉलर का। और वो जब आता है ना तो सब इंडियन भी ना, जो हम तुम्हारे जैसे कहीं भी चलते हैं गाड़ी में से उठाया खाया बाहर, है ना, वहाँ पे क्या करते हैं, जेब में रख लेते हैं, नहीं तो गाड़ी में ही पन्नी लेके चलते हैं, भैया इसमें डालते रहो, बाहर मत फेंक देना, है ना, डंडा।
तो ये तो म्युनिसिपैलिटी ने 2 तरह की बाल्टी दी थी, डस्टबिन वाली, गीला कूड़ा सूखा कूड़ा, और 50% घरों में वो बाथरूम में मिलती है, यूज करते हैं। हाँ, बाल्टी थी, फ्री ऑफ कॉस्ट बाल्टी थी।
मैं यही बता रहा हूँ आपको, कारण है हम खुद, मैंने बताया था ना, वो आदमी जानवरों को सबको बंद कर दिया था तो सब साफ हो गया था। तो यही है, एक ही मात्र तरीका है, सबको बंद कर दो तब साफ करो। तो ये पानी भी है, ऑटोमेटिकली सबको साफ करो आप। तो ये प्रॉब्लम तभी सॉल्व होगी जब हम सुधरेंगे, और हम सुधरते नहीं हैं। कौन देख रहा है, कौन कह रहा है, कोई कुछ नहीं हो रहा। हम लोग सब फेंकते हैं, चीज़ों को डिस्ट्रॉय करते हैं। तो ये क्या है, वाटर फ्रेश, देखिए द प्रॉब्लम्स टू डील विद रिड्यूस फ्रेश वाटर अवेलेबिलिटी, इंक्रीजिंग वेस्ट वाटर जनरेशन इन कमिंग डिकेड, राइट। क्योंकि हर चीज़ में हमारा तरीका बदल गया। वॉशिंग मशीन सेमी ऑटोमेटिक है, कम पानी लगता है, एक बार डाल दीजिए, फिर को कपड़े निकालिए, दूसरे डाल दीजिए। ऑटोमेटिक वॉशिंग मशीन, जब तक वो कपड़ा धुल के बाहर नहीं आ जाएगा सारा पानी, तब आप दोबारा डालिए, दोबारा वॉशिंग पाउडर डालिए, दोबारा डालिए, राइट। बढ़ दिया। छोटा सा डिफरेंस है सेमी ऑटोमेटिक एंड ऑटोमेटिक मशीन, है ना। तो ये जो चीज़ है, इससे क्या हो रहा है, कंजम्पशन इंक्रीज कर रहा है। फिर दूसरा, पहले मम्मी कैसे कपड़े धोती थी, हाथ से, थपकी से, हाँ, निकाले डाल दिए। चद्दर हो, दुतई हो, आज तुमसे कह दो तो पसीने आ जाएंगे, तुमको पता चला बाथरूम में गिर गई कपड़े धोने के चक्कर में, है ना। इसलिए वॉशिंग मशीन चाहिए। तो व्हाट वी हैव डू, हमने क्या किया, वह इंक्रीज ओवर कंजम्पशन पानी की, जबकि हम जानते हैं पानी नहीं है। पढ़े लिखे हैं ना, सब पढ़े लिखे हैं, हम सब जानते हैं पानी नहीं है। और 1 घंटे पानी बंद कर दो, त्राही त्राही हो जाती है, अरे बाप रे पानी नहीं आ रहा, पानी क्यों नहीं आ रहा, पानी क्यों नहीं आ रहा। हाँ मम्मी से पूछना पहली बार डॉक्टर के यहाँ कब गई थी। हाँ पूछना, जाएगी ना घर पे, पूछना पहली बार डॉक्टर के यहाँ कब गई थी। फिर भाभी से पूछना कब गई थी, तेरे को डिफरेंस पता चल जाएगा। मम्मी के अस्पताल जाने में और भाभी के जाने में या तुम्हारे जाने में क्या डिफरेंस है ना, वो पता चल जाएगा। कारण वर्क कल्चर। आज बोलती है ना, वो वॉक करो, योगा में जाओ, तो डांस में जाओ, तो वहाँ जाओ। नहीं, आज कह दो किसी को घर का पोछा झाड़ू पुचारा कर ले बहू से, तो चप्पल निकाल के मारेगी। 4 दिन बाद पता चला सास भी बाहर, ससुर भी बाहर। और किसी काम वाली बाई को देखा तूने, हैवी मोटी, सबके घर में आती है ना काम वाली बाई, तो देखिए किसी को हैवी चबड़ी बिल्कुल, और घर की बहुआ देख लो तो कुछ दिनों बाद कुछ कईयों को तो क्रेन से उठाना पड़ता है कि भैया उठा, नहीं तो चल ना पाएगी। तो क्यों? हमने वी रिड्यूस ओवर फिजिकल लेबर। पहले नलका चलाती थी माएँ, खाना बनाती थी, बर्तन मांजती थी, कपड़े धोती थी, झाड़ू पुचारा करती थी। तो उससे क्या होती थी? उनकी फिजिकल एक्सरसाइज होती थी, उन्हें डॉक्टर के पास जाने की जरूरत नहीं पड़ती थी, वो सिर में दर्द लेके नहीं पड़ी रहती थी। तो वो जो है, जैसे जैसे नॉन नेचुरल, जैसे जैसे हमारे पास सुविधाएं बढ़ेंगी, वेस्टर्न कल्चर है ये, मैं इसलिए कह रहा हूँ आपसे, ये वेस्टर्न कल्चर की देन है हमारे यहाँ, इंडियन कल्चर में नहीं है वो। आज आप इसको देख लीजिए, है ना। बहुत बहुत लोगों की मम्मी को काम वाली बाई का खाना समझ में नहीं आता, वो आज भी अपने हाथ से रोटी बनाना पसंद करती हैं। है ना। तो ये जो है ना, ये हमारा यहाँ का कल्चर नहीं है। हमारे यहाँ कल्चर है वर्क कल्चर, है ना। हमारे यहाँ वैसा कल्चर नहीं है कि नहीं साहब ब्रेड ले आओ, फ्रोजन ये ले आओ, फ्रोजन ले आओ। वो सब फ्रोजन ही खाते हैं उनका, क्योंकि उसी तरह का लाइफ स्टाइल है, तो फ्रोजन पे जीते हैं। हमारे यहाँ तो सब चीज़ उगता है, उनके यहाँ कोई एक चीज़ उगती है तो दूसरी चीज़ उनको विदेश से मंगानी पड़ती है। तो ये जो प्रॉब्लम है ना, दैट इज़ क्रिएटेड बाय अस। तो ये सब हम चीज़ जो हैं, सो वेस्ट वाटर का डिस्पोजल मेन देखिए, रिवर है, पॉन्ड्स हैं, लेक है, एग्रीकल्चर लैंड है, डायरेक्टली इनटू रिवर है, वाटर डिस्चार्ज रिवर इनटू एग्रीकल्चर लैंड है, एंड ओशियन एंड बेज है, डिफरेंट अबाउट 25% ऑफ टोटल वाटर। हमको जहाँ भी नेचुरल वाटर का रिसोर्स मिल रहा है वहीं हम उस पानी को डिस्चार्ज करते रहे, उसको ट्रीट नहीं कर रहे हैं, डायरेक्ट भेज रहे हैं, डायरेक्ट, है ना। एक कलेक्शन पूरा वेस्ट वाटर के ऊपर हो गया, ठीक है। दिल्ली का इलेक्शन चुनाव यमुना जी के ऊपर हो गया। सो यू कैन सी द इंपॉर्टेंस ऑफ वाटर एंड क्लीन वाटर बेसिकली। सो क्या है, पास्ट में क्या था, वेस्ट वाटर इज अ प्रॉब्लम, नाउ इट इज रिसोर्स, मनी है। 3,000 से लेके 50,000 तक का, 1.5 लाख का, 2 लाख का वाटर सॉफ्टनर, वाटर ट्रीटमेंट प्लांट, उसके बाद रनिंग कॉस्ट। ठीक, आप एक बार लगवा लीजिए, फिर आपको जरूरत पड़ने ही वाली है। अब उसका ये खराब हो गया तो अब ये बदलवाइए, तो ये बदलवाइए, ये बदलवाइए, इन्वेस्टमेंट फटाफट। रेस्क्यू आपके पास आ गया, रिसोर्स जनरेशन शुरू हो गया। एक टाइम था जब लगता था वेस्ट वाटर प्रॉब्लम है, आज नहीं है। आज वो मार्केट का एक बहुत बड़ा हिस्सा है, जहाँ पे आपको, है ना, घर से पानी भर के लेके चलते हैं, नहीं ना, मालूम है हर जगह दुकान से बिस्लरी मिल जाएगी 20 रुपए की, फट से पिक करते हैं ना। सोचते हैं? नहीं सोचते। उसके बाद उस बॉटल का क्या करना है सोचते हैं? नहीं सोचते। खाली हुई, वो गई। तो क्या हो गया, एक पूरी इंडस्ट्री रेडी कर ली है हमने अपने यहाँ वेस्ट वाटर की, ड्रिंकिंग वाटर की, जो आपको ट्रीट करके दे रहा है, राइट। आप किसी डेवलप कंट्री में चली जाइए, किसी के घर में आपको आरओ नहीं मिलेगा, किसी के घर में आपको आरओ नहीं मिलेगा। सब पानी पीते हैं म्युनिसिपल वाटर का, सबके घर में टंकी से आ रहा है, टंकी खोलिए, पानी लीजिए, पानी पीजिए। और उन्होंने आप क्या कर दिया, आपको डरा डरा के आपका पानी गंदा, नलके वाला पानी गंदा है क्या? नहीं, हाँ गंदा करके माइंड सेट ऐसा कर दिया, सबके घर में आरओ लगवा दिया, सबके घरों में आरओ है ना। अच्छा, एक और कमाल की बात है, आप और हम सब पढ़े लिखे इंजीनियर्स हैं, है ना, इंजीनियर है ना सब लोग, आप लोग क्या, नहीं कोई बात नहीं, इंजीनियर में मान के चलता हूँ। क्या टेस्ट करते हैं भाई? टीडीएस, बस खुश। वो आया आरओ वाला, उसने निकाली वो, हाँ सर इसका टीडीएस इतना बढ़ गया है, 250 हो रहा है, मैं इसको 110 कर दे रहा हूँ। आप भी खुश, वाह भाई वाह, TDS बदलवा दिया भाई। इसका pH कितना है? वो मुझे भी नहीं पता जी। इसमें और बाकी क्या क्या आ रहा है भाई, पता है? मुझे नहीं पता जी। वो TDS से आपको बेवकूफ़ बना के चला जा रहा है और आप बन रहे हैं। कमाल देखिए। उससे पूछिए भाई कैल्शियम कार्बोनेट कितना है इसमें, कौन सा क्या है, ये कौन सा, ये जो तू बैक्टीरिया लगाया है ये कौन से वाला बैक्टीरिया मार रहा है, मेरे वाटर में कौन सा बैक्टीरिया पाया गया। वो ऐसे हाथ हिलाएगा और आपको टाटा कर देगा, सॉरी आई डोंट नो। बस TDS आपका ठीक किया और पैसे लिए, विजिटिंग चार्ज 200 रुपये 500 रुपये, और चल मेरे भाई। क्या बहुत अच्छी बात है, बिल्कुल सही है, नेचुरल प्रोसेस है, ठीक है ना। जब तक ठीक है, जब तक घड़े का पानी पी। एक बार आदत पड़ी, गए काम से, है ना। तो वो एक प्रॉब्लम्स है। तो अब इसमें क्या आया, देखिए न्यू वाटर स्कीम इन सिंगापुर में उन्होंने यूज़ की। क्या किया? ट्रीटेड डोमेस्टिक वाटर फॉर इंडस्ट्रियल यूज़। जो पानी हम घर में यूज़ कर रहे हैं, बाथ में यूज़ कर रहे हैं, वॉशिंग में यूज़ कर रहे हैं, वो सब वो कलेक्ट करते हैं और उसको भेज देते हैं इंडस्ट्री में। भाई अब तुम इसे यूज़ कर लो, राइट। आप अंडरग्राउंड वाटर यूज़ मत करिए, बोरवेल का पानी यूज़ मत करिए, आप इस वाटर को करिए, ठीक है। वो उन्होंने क्या किया, ये करने लगे। दूसरा, जीरो डिस्चार्ज फ्रॉम द मेजर इंडस्ट्री। ये जीरो डिस्चार्ज जो है अब आपके यहाँ भी लागू हो रहा है। सेंट्रल पोल्यूशन कंट्रोल बोर्ड इस तरह से मॉनिटर कर रहा है ट्रीटमेंट को कि आप इंडस्ट्री जो पानी निकाल रही है उसको डिस्चार्ज नहीं करे, या तो उसको रीयूज़ करे या उसको इरिगेशन में यूज़ करे, ठीक है। तो जीरो डिस्चार्ज के ऊपर काम कर रहे हैं कि एक बूंद पानी जो है इंडस्ट्री से बाहर न जाए। उसके ऊपर इंडस्ट्री के ऊपर एक अच्छी खासी पेनल्टी है आज, अभी, अदरवाइज पहले नहीं थी, पहले सब था, ठीक है। पिछले करीबन 8 साल से मैं इस प्रोजेक्ट में लगा हुआ हूँ और काफ़ी कुछ सिनेरियो चेंज हो गया है। पहले तो लोगों को मालूम ही नहीं था कि वेस्ट वाटर प्लांट होता क्या है। इंडस्ट्री लगा ली है लाला जी ने, हुआ प्रोसेस का पानी नाले में, बगल के नाले में या नाली से, सब। अब धीरे धीरे काफ़ी कुछ इम्प्रूवमेंट हो रहा है ऑन जीरो डिस्चार्ज। देन रिसाइकल्ड वाटर फॉर डोमेस्टिक यूज़, राइट। जैसे सिंपल सा एग्जांपल लीजिए, आपका जो बाथ का पानी है उसको वापस आप टॉयलेट में यूज़ करिए। आप उसको क्यों बहने देते हैं? उसमें भी तो 1 बाल्टी 3 बाल्टी पानी जाता है ना वंस फ्लैश में, तो आप उसको वहाँ यूज़ करिए, या आप उसको रिकलेक्ट करिए, देन अगेन रीयूज़ करिए। तो वाटर को रीयूज़ करना इज ईजी देन ट्रीटेड वाटर फॉर ग्राउंड वाटर रिचार्ज एंड इरिगेशन। क्योंकि अगर ग्राउंड वाटर रिचार्ज रहेगा देन अगेन यू विल गेट द फ्रेश वाटर एंड अदरवाइज यू कैन यूज इन योर इरिगेशन पर्पस, राइट। बट इट इज पॉसिबल ओनली इन सिंगापुर, हमारे यहाँ नहीं है, ठीक है सर। हमारे यहाँ बहुत सारों के घरों में ऐसा है, अगर आपसे कहूँ मैं एक पेड़ लगा लो, खड्डा खोद के लगा नहीं सकते, क्योंकि दीवार से दीवार मिली हुई है, सड़क पे हम कब्जा करने को तैयार हैं, है ना, सड़क पे कब्जा करने को तैयार है और दीवार से दीवार मिली हुई है। हमारे यहाँ कोई सेंस है ही नहीं। हमारे यहाँ 99% घरों में रेन वाटर हार्वेस्टिंग है ही नहीं। जितना अब ये कह रहे हैं सब, वो मुजफ्फरनगर में वो वहाँ पे कहाँ वो शिवजी जी की मूर्ति के पास पानी भर गया अभी बरसात में ना, कल की न्यूज़ है शायद, परसों की न्यूज़ है। वो भरेगा ही भाई, वो जाएगा कहाँ? क्योंकि साल भर तो नाली भरी तुमने पन्नियों से, झाड़ू मारेंगे, मिट्टी भी नाली में, कचरा भी नाली में, दुकान के सामने साफ। आओ गाली किसको? म्युनिसिपल कॉरपोरेशन, ये नालियाँ साफ नहीं हुई। मैं नाली साफ भी कर देंगे तो उसे आप फिर भरोगे साल भर? बरसात के पहले हर कोई म्यूनिसिपल कॉरपोरेशन यही चाहता है, भैया नालियाँ साफ़ कर लो, नहीं तो ये फिर हल्ला मचेगा। लेकिन हम साल भर उसको भरने का काम करते हैं। तो ये हमारे यहाँ ये इसलिए पॉसिबल है इन सिंगापुर, जहाँ पे कुछ रूल एंड रेगुलेशन है ना, हमारे यहाँ नहीं है। सो क्या करना है? टू डेवलप टेलर मेड ट्रीटमेंट प्रोसेस फॉर वेरियस सिचुएशंस, वेस्ट वाटर ट्रीटमेंट, यूज़ एंड रिसाइकिल, लाइफ साइकिल एनालिसिस ऑफ वाटर ट्रीटमेंट सिस्टम। कब तक चलेगा? लाइफ साइकिल क्या है उसकी? ऐसा तो नहीं कि 10 साल बाद फिर से बदलना पड़ेगा, या एक नई यूनिट तो नहीं लगानी पड़ेगी, इससे काम ना चले कुछ और लगाना पड़े। ठीक है, प्राइमरी से हम सेकेंडरी भी लगाए, सेकेंडरी से टर्सरी भी लगाए हैं। आजकल आप चले जाइए हर जगह बायोलॉजिकल ट्रीटमेंट के बड़े बड़े रिएक्टर लगे हुए हैं। तो धीरे धीरे कंपनी का जो है पैसा इन सब चीज़ों में एडवांसमेंट में खर्च हो रहा है। ठीक है ना? सो वी वर्क ऑन जीरो डिस्चार्ज। ये देखिए डिफरेंट कैटेगरीज हैं, पेस्टिसाइड्स है, हर्बिसाइड्स है, ठीक है, इंडस्ट्रियल एडिटिव्स हैं, गैसोलिन हैं, एडिटिव्स है, फार्मास्यूटिकल है, फिनोनिक कंपाउंड है, लाइफ साइकिल कंपाउंड्स है, सफिशिएंट एंड देयर रेसिड्यू है, ऑड्स एंड टेस्ट है, एंड माइक्रोप्लास्टिक्स है। ये सब आजकल जो हैं बहुत प्रोसेस हैं जो आप इसमें पोल्यूशन में आपको मिल रहे हैं। ये हमारे डिफरेंट प्रोसेस हैं विच यू हैव ऑलरेडी नोज, फिजिकल प्रोसेस, केमिकल प्रोसेस एंड बायोलॉजिकल प्रोसेस इस देन प्राइमरी ट्रीटमेंट, स्क्रीनिंग है, ट्रैप्स है, ग्रिड चैम्बर्स है, सेप्टिक टैंक्स है, इनहॉफ टैंक्स है, सेडिमेंटेशन टैंक है, एनारोबिक बफल रिएक्टर्स हैं। सेकेंडरी ट्रीटमेंट में एक्टिवेटेड स्लस प्रोसेस है, ट्रिकलिंग फिल्टर है, वेस्ट स्टेबलाइजेशन पाउंड है, एनारोबिक लगून है। दीज आर ऑल डिफरेंट, है ना? दिस सो टर्सरी ट्रीटमेंट में क्लोरीनेशन है, ओजोन है, मेम्ब्रेन फिल्ट्रेशन है, माइक्रो फिल्ट्रेशन है, अल्ट्रा फिल्ट्रेशन है, एंड नैनो फिल्ट्रेशन मेम्ब्रेन है, एंड रिवर्स ऑस्मोसिस है। ये सब प्रोसेस हैं आपके टर्सरी की। अब आइए,
क्या ऐसा सोल्यूशन है जो हम यूज कर सकते हैं, स्पेशली अगर कोई बीमार है खुद से, तो हम पानी को कैसे चेक करें या उसको कैसे हम क्लीन करके हम यूज करें?
नहीं, इसीलिए तो मैंने आपसे बताया ना, इसीलिए हम लोग फिल्ट्रेशन पर्पस यूज़ करते हैं ना, फिल्टर इसीलिए लगाते हैं। आरओ एंड या अगर आप सिंपल फिल्टर भी लगाएंगे पानी के अंदर, फिल्ट्रेशन अलग सिस्टम आता है जिसमें दो रहते हैं, एक एक्टिवेटेड कार्बन फिल्टर होता है, एक माइक्रोब फिल्टर रहता है। उसको भी लगाएंगे तो भी क्लीन हो जाता है। बेसिकली प्रॉब्लम तब आती है जब व्हेन यू ड्रिंक माइक्रोप्लास्टिक इन योर वाटर। आप आधा घंटा उसको प्लास्टिक की बॉटल्स को, जिसको पानी को पीते हैं, सनलाइट में रख दीजिए, है ना? तो क्या होगा? वो प्लास्टिक की बॉटल बनती किससे? केमिकल से। तो क्या होगा? उसका जो केमिकल है वो लीचेट करेगा आपके पानी के अंदर। इसीलिए आपने देखा होगा जितनी भी आप पानी की बॉटल्स मार्केट से परचेज करते हो सब ठंडी होती हैं, फ्रिज से निकली हुई। कोई आपको बाहर रखी हुई बॉटल कभी नहीं बेचेगा। ये इंस्ट्रक्शन होता है उनको कि आप इसको कोल्ड टेम्परेचर में रखिए, अदरवाइज क्या होगा? प्लास्टिक वाटर के साथ रिएक्ट करेगा और उसमें ओजोनेशन है। वैसे तो बनता नहीं है पानी, खाली के खाली सिंपल वाटर है वो ना, है ना? तो ओजोनेशन उसमें किया जाता है, उसके बाद उसको फिल किया जाता है, तब वो आपके पास सेल कर रहा है ना। 20 रुपए इसी बात के ले रहा है ना वो, है ना? तो वो क्या करेगा? आफ्टर ए सर्टेन टेम्परेचर पे वो रिएक्ट करने लगेगा पानी के साथ। उसमें है ना वो केमिकल बना हुआ है, ओजोनेशन आप पढ़िए, उसमें वो केमिकल रिएक्ट करेगा। तो क्या होगा? पानी के अंदर उसकी प्लास्टिक की जो प्रॉपर्टीज़ हैं वो पानी के अंदर आने लगेंगी। इसलिए ठंडी बॉटल्स वो आपको प्रोवाइड कराता है ना? गर्म बॉटल नहीं देता वो। सो नाउ जो बेसिकली विच आई एम हेयर टू डिस्कस लेटेस्ट टेक्नोलॉजी, यही था ना टॉपिक, यही है। अभी तक हमने सब इंट्रोडक्शन किया, अब आता है लेटेस्ट टेक्नोलॉजी. और लेटेस्ट टेक्नोलॉजी मीन्स इज जस्ट लाइक एन अ लेटेस्ट कार, मीन्स मोर मनी, राइट. तो हर टेक्नोलॉजी के डिफरेंट एडवांटेजेस हैं, डिफरेंट डिसएडवांटेजेस. वो मैं लास्ट में आपको स्लाइड दिखाता हूँ. तो अभी हम बात करते हैं मेम्ब्रेन. सब खूब पढ़ते हैं मेम्ब्रेन मेम्ब्रेन मेम्ब्रेन. सो क्या प्रॉब्लम? फर्स्ट इज कॉस्टली होती है. प्रोसेस इज कॉस्टली, राइट. यू कांट रिप्लेस रेगुलरली. ठीक. आफ्टर सर्टेन टाइम इट फॉइलिंग फैक्टर विल इंक्रीज, मीन्स द कैपेसिटी ऑफ द मेम्ब्रेन विल रिड्यूस. तो अभी जितना आपको अमाउंट आप उसको ट्रीट करना चाहते हैं वो कर ही नहीं पाएगा. तो ये सब चीज़ें जो हैं. और फिर दूसरा क्या है? ड्राइविंग फोर्स. आपको प्रेशर चाहिए. देन अगेन प्रेशर के लिए आपको पंप चाहिए. थ्रू बिना पंप के आप प्रेशर क्रिएट नहीं कर पाएंगे. तो वो सब चीज़ें जो हैं वो प्रोसेस को या एडवांस प्रोसेस को कॉस्टली बनाते हैं. बेसिकली दीज आर ऑल कॉस्टली अफेयर्स, राइट. So membrane technology, so I just given you the one how we use membrane technology. Separate substance for forcing a solution through semi-permeable membranes that allow some component to pass while blocking others. The separation is based on different in size, charge and other properties between the substance in the solution. Pressure is often used as in a driving force, and the driving force are like concentrated or electrical potential gradient also can be employed. So plus and minus both charge we will give to the membrane reactors. So selective permeability, so we divide is design and a specific pore size and other properties like to allow to certain molecular and particles to pass through the with to blocking each other, right. So that it will not cross the membrane. Otherwise क्या होगा? It will comes to the another process if it will be cross the membrane. So we use this type of. So driving forces is the pressure commonly used to push the solution to the membrane is concentrated gradient, or in dialysis and osmosis electrical potential gradient. In electrolysis can also be applied. Absorption, sieving and electrostatic phenomena. So now we use membrane bioreactors. तो ये this type is, अभी तक तो आपने पढ़ा is a membrane. Now membrane bioreactor where we generate microorganisms so that it can kill the bacteria or they can eat the bacteria. So they need food, so they will take from the wastewater, so which come we are provide to the our reactor. So this will be, so is a basically microfiltration and ultrafiltration for suspended growth of bioreactor. So this is basically both we are using municipal and industrial wastewater treatment. So bioreactor is basically designed chamber to support biological activities environment, mainly where bacteria and protozoa, so that we can say the biomass can grow and consume small or all substance within the raw wastewater. So we develop this type of atmosphere in our bioreactors so that our bacteria will grow properly, and then right, so that it will treat our wastewater, right. So it can be aerobic, anaerobic, and anaerobics is depending on the presence of oxygen and nitrates or the substance. So it will basically depend upon the oxygen concentration, what type of bioreactor you will use. Yes. So because you can see now the microfiltration is raw waters which we have different type of bacterias और pollutant, इसमें suspended particles भी हैं, oil emissions भी हैं, colloidal भी है, micromolecules भी है, proteins भी है, सब है. So it will, what we do, microfiltration, then ultrafiltration, then nanofiltration, and then reverse osmosis. These are the different processes which we use one by one, but all remove 10 to 0.01 micron, 0.1 to 0.1 micron, 0.01 to 0.001 micron, and 0.001 micron to 0.0001 micron. Now you can see हम लोग कहाँ पहुँच गए, 0.0001 माइक्रोन तक पहुँच गए, right? So it will, so we need to remove this, we need reverse osmosis. Simple process it, we can't remove this type of contaminants in our wastewater, so we need reverse osmosis. So similarly, microfiltration we need 0.2 to 5 bar, ultrafiltration we need 1 to 10 bar, nanofiltration 5 to 10 bar, and reverse osmosis we 10 to 150 bar pressure. We need this type of pressure for our process, right? So basically 3 type of bioreactors we use. In first is suspended growth bioreactors, second is attached growth, which we can say the biofilm bioreactor, and hybrid bioreactor. So it will be basically, hybrid is for combined suspended and attached growth bioreactors. So then with this type of bioreactor we use for MRV process, and then different type of membrane for micro ultrafiltrations for we use in our process. So its typically ultrafiltration membrane is preferred choice because of their superior separation characteristics and low foiling tendency to allow the rest for, right? So there are 3 type of membrane, is hollow fibers, sheet, flat sheet, and tubular we use. So these are the different membrane filtration process. This is bioreactors. So then effluent for membrane, so this is for backwash, so that we can clean our membrane. So this type of process we use for wastewater treatment using membrane filtrant. Then integrated membrane bioreactor we use, and then biomass separation and process aeration enhancement. So we use in this process. So similarly, if we use bioreactor, then we use clarifier, and then again membrane process, membrane filtration, so that we can get the effluent. So this type of different process we use in our. So here different what is passed through the in microfiltration, ultrafiltration, nanofiltration, and reverse osmosis. ये आपका है डिफरेंट टाइप का जहाँ पे इंटरेक्शन होता है. सो क्या एप्लीकेशंस है अभी what we are using? Microfiltrations and ultrafiltration for suspended solid removal, turbidity, and some microorganisms. Removal of dissolved salt and iron, water reuse, irrigation with others technologies, and what is the different future aspects is advanced membrane materials, ठीक, so that we can improve higher permeability, enhancement selectivity, and greater final resistance. So novel membrane process, emerging technology like forward reverse osmosis, membrane distillations, and the other potential energy efficient wastewater treatment and resource recovery. Decentralized wastewater treatment, membrane technology is well suitable for decentralized treatment systems, offering flexibility and reducing the need of the extensive infrastructure. Then the resource recovery, integration and artificial intelligence we are using now in our wastewater treatment, right? AI, MI, we are using in nowadays in our wastewater. So what we are basically, so that we can predict the life of our process. वही है basically data monitoring, so that in this we can use AI or machine learning process in our process. So what is the different challenges in membrane is membrane fouling, energy consumptions, right, and cost effectiveness. So this is the basically cost effectiveness, initial cost and operation cost of membrane system can be barrier through the widespread adoption requiring further cost of reduction strategies, है ना. आप जब भी अपना मेम्ब्रेन वो मंगाते हैं वो उठा के आता है सर इसको फेंक दीजिए, तो क्या होता है वो तो वेयर वी कैन easily affordable, but in industry it's not easily affordable कि हम मेम्ब्रेन उसको बार बार रिचार्ज कर सके या हम उसको बदल सके, तो उनको दे नीड लाइफ. So this is reverse osmosis. It's contaminant including salt, dissolved organic matters, heavy metals and fresh water. So this is basically solvent, or you can say wastewater. This is semi-permeable membrane and this is our concentrated membrane. So this is osmotic pressure se we make osmosis. Then this reverse osmosis, we use external process pressure. And the same seawater, this is permissible membrane, and this we get the fresh water. Here we use pressure. So now nanofiltration is the mild RO and ultrafiltration effectively remove the diluent ions and large molecules. So now come to the, now you both of you have heard about advanced oxidation process. So what we do in advanced oxidation process, we use OH ion so that it will react with the water, OH ion, then they produce carbon dioxide and water. Na? So we use OH ion as a reactant in the water, right? So we have OH as degrade the and mineralize organic pollutant in water and wastewater. This is a radical and powerful oxidant and can break down complex contaminants into less harmful substance like water, carbon dioxide and inorganic salt. We convert it. So photocatalytic oxidation, ozonations and electro oxidation. Photocatalytic oxidation, we use sunlight and we convert sunlight use as a medium for oxidation process. Then ozonation, we use ozone gas to oxidize and remove contaminant in wastewater. Electro-oxidation, we use electrochemical reactions which we oxidize and remove pollutant with techniques with electrochemicals. So here you can see, so we use different bacteria, virus, OH oxidations, and then we get H2O and CO2. This is our electrochemical process where we have anode and cathode, where we use positive and negative charge, and we through convert in pollutants. And this is advanced oxidation process with ozonation, ultraviolet and H2O2, right? Say again, what is the different combinations? कहाँ use कर रहे हैं? We are using in wastewater treatment is widely industrial wastewater, drinking water, and we can remove broad spectrum of organic pollutant, reduce toxicity and improve biodegradability. Groundwater remediations. So groundwater source is including pesticide, algae, toxin and other emerging pollutant. Air purifications, we use air purifier, odd eliminations and removal of volatile organic compound. Then soil recommendation. So we degrade pollutant and improve the soil quality by using this. So we have specific applications in food industry, pharmaceutical industry and bioenergy sector. And what is the future aspect? Integration and other technology. So we use chemical properties, physical, and this we have governing factor in catalyst. So development of first is development of novel catalyst so that we can easily degrade our pollutant so that we can remove, and then cost reduction and energy efficient. So because if you use only power, sun power, then it is still not cost effective, because you need some medium to get the energy from the sun, right? Similarly, the all chemical process which we use, whether you are using H2O2, whether you are using ultraviolet process, these are all processes are very costly. So then they require your money. So you need the cost effective process. And resource recovery then can be recovery from water, such as valuable material and other products. So you have to improve process optimization. So technology. So this convection method, established recovery process is solvent extraction, evaporation, oxidation, electrochemical treatment, membrane and membrane bioreactor and ice. Now the emerging after this step is advanced oxidation process, adsorptions onto non-conventional solids, bioabsorptions, biomass and nanofiltration is our emerging technology. So now come to the microbial fuel cell, which we use in our recovery for the. So what is convert chemical energy into electrical energy by the microorganisms, right? And then specific bacteria oxidize organic matters anode at anode and release electrons or protons. So this is I have summarized in anode chamber what happened in our microbial cell. Microbial oxidation, bacteria is introduced on the anode chambers along with organic matter. Then electron release, the bacterial metallize organic matters oxidizing and its release electrons and protons of the product. Then electron collections, the anode typically made by carbon based materials collect these electrons and then flow through the external core. Similarly, cathode chamber, that we have two different chamber, anode and cathode. Then the proton produced in the anode moves through the membranes. Electron acceptance, the electrons moving travels through the external current, and water formations is at the cathode end for electrons, protons and oxygen from here combined with water and complete the circle, so that we can get carbon dioxide and water from the microbial fuel cell, right? So this is the electrochemical system and potential of energy recovery. So you can see this is anode and cathode. So this is organic wastewater. It will react with the cathode with carbon dioxide and H plus ion. Then here we can get the H2O react with the oxygen, right? So it will having different component of MFC, anode, cathode and anaerobic chamber, electrode catalyst and proton exchange systems and cathodic chambers. So we are having different type of components. So again, what is the application of several fuel cell? Again, wastewater treatment we are using, renewable energy production we are using, right? So that we can get the energy cell instead of others, right? तो ये जो है ये आज का सबसे बड़ा मतलब आप ये समझिए रिसर्च का सबसे बड़ा इंटरेस्ट है सेल, फ्यूल सेल, है ना? तो धीरे धीरे आप जानते हैं सब, हम लोगों को धीरे धीरे कहाँ शिफ्ट करना है? इलेक्ट्रिक व्हीकल्स पे शिफ्ट करना है. तो इलेक्ट्रिक व्हीकल पे हम लोगों को क्या चाहिए? सेल चाहिए. तो आज के टाइम में सबसे ज़्यादा जो गवर्नमेंट, सेंट्रल गवर्नमेंट जो है वो इन्वेस्ट कर रही है वो सेल के ऊपर. तो अगर आप उसके ऊपर कोई प्रोजेक्ट लिखते हैं, कहीं सबमिट करते हैं, तो यू कैन गेट गुड अमाउंट ऑफ मनी, राइट? गुड प्रोजेक्ट, ठीक है? सो रिन्यूएबल एनर्जी, बायोरेमेडिएशंस, बायोसेंसर, बायोफ्यूल. सो दिस इज द बेसिकली केमिकल रिएक्शंस at anode CH3COOH plus H2, CO2 plus 8H plus 8 electrons. Cathode में 2CO2 plus 8 8H plus 8 as H2O. Overall reaction is CS3 COOH plus 2H2O is give 2H2O plus CO2 plus electricity and biomass. This is the basic chemical reactions in MCF. So these are the different application: wastewater, bioelectrical generation, biohydrogen productions, and other application is dye decolorization, desalination, sensor, bioremediation, carbon capture, right? Or biosensor and different type of hazardous waste you can easily use. So this type of bioelectric you can easily use in your wastewater treatment also. So you can use here as a source of energy. So then it will go for the tertiary treatment and then wastewater for reuse, so that you can reduce your electricity bill. Instead you can use your electricity. So what is the future aspects kya hai? You can scaling up for large scale industrial and commercial applications, improving efficiency. You can advancement in cathodes and other different type of reactor design. Then you can see cost reductions for develop low cost materials, optimizing FC design and crucial for widespread adoption, integrated with different technologies so that you can use microbial electrocells and other more efficient resource recovery and decentralized energy systems, so that contribute to the decentralized systems or more sustainable and realistic energy supply, achievement sustainable development goal, so that can be sustainable development is release clean water and sustain affordable and clean energy, suitable cities and communities, right? तो अभी क्या हो रहा है, अगर आप अपने घर पे सोलर एनर्जी लगाते हैं तो पहले क्या होता था, हमको सोलर के लिए बैटरी खरीदनी पड़ती थी, राइट? और आफ्टर सर्टेन टाइम के बाद आप उस सेल को कह देते जाइए फेंकिए बेयर, है ना, कोई इंटरेस्ट नहीं था. अब क्या हो रहा है, अब सरकार आपसे बोलती है कि आप सोलर का लगाइए एंड डायरेक्ट सेंड टू द ग्रिड, आपको स्टोर करने की ज़रूरत ही नहीं है. तो जो जितनी भी एनर्जी आप प्रोड्यूस करते हैं सेल से, उतना आपका रिडक्शन होकर आपका बिल आता है. आपका बिल उतना ही रिडक्शन हो गया. मान लो सपोज आपने 1000 रुपये की बिजली कंज्यूम की अपने मीटर से और 500 रुपये की आपने वहाँ भेजी, तो आपको मात्र 500 रुपये ही देना है, 500 रुपीज़. तो दिस टाइप ऑफ इनिशिएटिव पहले हम लोग करते थे कि हमको बैटरी रखनी पड़ती थी, रिचार्ज करते थे. आफ्टर सर्टेन, क्योंकि उसकी एक लाइफ है ना, सर्टेन लाइफ है. जैसे मोटरसाइकिल की बैटरी की एक लाइफ है, कार की बैटरी की एक लाइफ है, उसके बाद उसको हमको डिस्कार्ड करना पड़ता है. लेकिन अब वो जो प्रॉब्लम्स था वो गवर्नमेंट ने, सेंट्रल गवर्नमेंट ने दूर कर दिया. आप ग्रिड को दीजिए, प्रोड्यूस करिए, ग्रिड को दीजिए, ग्रिड ऑटोमेटिकली आपके बिल से उसको रिड्यूस करेगा. तो बहुत जगह लोग इसका काफ़ी अच्छा यूज़ कर रहे हैं. उज्ज्वला योजना, ये सब जो, ठीक है. नाउ डिजिटलाइजेशन एंड ऑटोमेशंस, है ना. अब ये सब डिजिटलाइजेशन होना, सब चीज़ें हो रही हैं. तो वाई वी नॉट गो फॉर डिजिटलाइजेशन एंड ऑटोमेशन इन आवर प्रोसेस, सो दैट आप जितना भी पहले काम करते थे हाथ से, अब कंप्यूटर पे बैठ के काम करते हैं, आपको कमांड देना होता. तो सेम प्रोसेस विल यूज इन आवर in this process. So what we get the informations and then we select the technology and then suitable technology, after then we execute, right, है ना. उसके हिसाब से we get the problem, solve the problems of our waste water treatment, right. So क्या प्रिंसिपल है डिजिटलाइजेशन का? इस कन्वर्जन ऑफ एनालॉग इंफॉर्मेशंस लाइक पेपर डॉक्यूमेंट, इमेज एंड फिजिकल प्रोसेस इनटू द डिजिटल फॉर्मेट, एंड ऑटोमेशंस बाय यूजिंग टेक्नोलॉजी टू परफॉर्म टास्क विद मिनिमम एंड नो ह्यूमन इंटरवेंशन, राइट. So these two, this is the basic principle for automation and right. So again we are using AI machine learning to optimize process of optimize treatment process, predict failure, improve overall plant efficiency. Real-time monitoring and control by using sensors, data analysis for adjustment of treatment parameters to ensure optimum performance. तो ये है डिजिटलाइजेशन. सो क्या करना है? व्हाट इज द एप्लीकेशंस? एनहेंसमेंट, मॉनिटरिंग एंड कंट्रोल, so that you can easily control the process parameters from the automation or the machine learning, right? It will help you to get the efficiency, है ना? तो efficiency बहुत ज़रूरी है, right? क्यों ज़रूरी है भाई efficiency? नहीं, पहले गाड़ी का कोई एवरेज देखता था? नहीं ना. आज देखते हैं कि वो कितने किलोमीटर पर, क्यों? जस्ट बिकॉज ऑफ प्राइस ऑफ डीजल और प्राइस ऑफ पेट्रोल, है ना. तो हमको क्या ज़रूरत है? एफिशिएंसी की. पहले हम नहीं करते थे कि हमको एफिशिएंसी इज़ एसेंशियल फॉर अस और नॉट. सस्ता था, चलाने वाले कम थे, इजीली अवेलेबल था, तो इसलिए हमने कभी उस तरफ सोचा ही नहीं. आज जब हम उसको यूज़ करते हैं तो हमको लगता है कि हमको चाहिए भी एवरेज, है ना. हमको ऑटोमेशन चाहिए. आज गाड़ी बता देती है ना कि चारों टायरों में कितना हवा है, आपको स्क्रीन पे दिखता है. कोई भी गाड़ी का फॉल्ट होगा तो आपको पहले वो स्क्रीन पे इंडिकेट करेगा जस्ट फ्रॉम द सेंसर. तो यू कैन ईजिली आइडेंटिफाई कि आपकी गाड़ी में क्या प्रॉब्लम है. पहले आपको यार पता नहीं क्या हो रहा है, मिस्त्री के पास जाते थे. अब लेकिन आपको पहले बताएगा कि ये प्रॉब्लम है, इसलिए आप मैकेनिक के पास जाइए, बिना वैसे मत जाइए, है ना. तो ये सब चीज़ें जो हैं, ये सब ऑटोमेशन और जस्ट बिकॉज ऑफ एआई की वजह से ये सब चीज़ें हम उसको क्या करते जा रहे हैं? ऑप्टिमाइज करते जा रहे हैं. हम चाहते हैं वी इन्वेस्ट लेस गेट मोर. ये ना हो कि हम इन्वेस्ट मोर गेट लेस करें, तो हमारा जो प्रोसेस सिस्टम है वो क्या होगा? ऑटोमेटिकली फेल हो जाएगा. सो देन अगेन, सो वी कैन प्रिडिक्ट मेंटेनेंस. मैंने जस्ट आपको एक एग्जांपल दिया. सो देन वी कैन इजीली प्रिडिक्ट मेंटेनेंस. हमको कहाँ ज़रूरत है? हमारा प्रोसेस ठीक से काम कर रहा है, नहीं कर रहा, हमारा बायो रिएक्टर ठीक से काम कर रहा है, नहीं कर रहा, क्या टेम्परेचर उसमें दिखा रहा है, इनर टेम्परेचर कितना है, आउटर टेम्परेचर कितना है, किस में क्या हो रहा है, ये सब चीज़ें यू कैन ईजिली काउंट. तो यू कैन ईजिली प्रिडिक्ट द मेंटेनेंस. ठीक है. इफ़ यू मेंटेनेंस होगा तो क्या होगा? आपका मिनिमाइजिंग डाउन टाइम होगा. डाउन टाइम, है ना. तो आपका प्रोसेस जो है कंटिन्यूसली चलेगा, तो आपका लॉस कम होगा. Then similarly you can easily process optimize कर सकते हैं, right? So such as aeration है, different process है, sludge maintenance है, chemical dosing है, leading of increase efficiency and reduce cost. आपके पास डाटा है, you can easily predict. So improve decision making, है ना. Improve your decision making. तो डिसीजन मेकिंग के लिए क्या फैक्टर है? फर्स्ट इज ऑप्टिमाइजेशन. कॉस्ट कम से कम होना चाहिए, बेटर ड्यूरेबिलिटी, है ना, लेस ह्यूमन एफर्ट. तो ये सब चीज़ें हमको हमारे उसमें काम आती है. अदरवाइज क्या होगा? प्रॉब्लम क्रिएट होगी. तो नाउ वी कैन इन फ्यूचर प्रोस्पेक्ट्स में स्मार्ट वाटर ट्रीटमेंट प्लांट में वी आर यूजिंग एआई एंड डिजिटल ट्विंस, सस्टेनेबल रिसोर्स मैनेजमेंट. वी आर अचीविंग सस्टेनेबल वाटर मैनेजमेंट, इंक्रीजिंग ऑटोमेशंस so that we can reduce human interventions and increase what? बेरोजगारी, अनएम्प्लॉयमेंट. ये वो वी आर क्रिएटिंग अनदर प्रॉब्लम, है ना. तो एआई मशीन लर्निंग क्या कर रहा है? आपकी बेरोजगारी बढ़ा रहा है. बेरोजगारी, ठीक है. वाइड एडॉप्शन इज डिजिटल टूल, इम्प्रूव पब्लिक हेल्थ, एनहेंसमेंट डाटा शेयरिंग. सो दिस टाइप ऑफ मॉनिटरिंग. Recently I have visited one company which is 4,000 crores, right? And I asked to the HR how many people you have in your industry? सर मीन्स मैंने कहा आपने कितने लोगों को हायर किया हुआ है? 4,000 करोड़ की कंपनी लगा रखे हो, कुछ तो किया होगा यार. एंड इज़ ए मैन्युफैक्चरिंग प्रोसेस प्लांट, ऐसा भी नहीं कि वो कुछ नहीं था, मैन्युफैक्चरिंग कंपनी प्रोसेस. उसने कहा सर 35 ऑन कंपनी पेरोल, 35 ऑन कंपनी पेरोल. मैंने कहा रेस्ट सब कॉन्ट्रैक्चुअल लेबर है, हम हायर ही नहीं करते. मैंने कहा प्रोसेस ऑटोमेटिक है सर, ज़रूरत ही नहीं है. आदमी कहाँ ज़रूरत पड़ती है? डिस्पैच में. समझ रहे हैं आप? ऑटोमेशन से क्या हुआ? पहले जब कोई एक कंपनी लगती थी ना, तो गांव के सब आदमियों को वहीं नौकरी लग जाती थी, क्योंकि सब काम हाथ से होते थे. एक शुगर मिल लगती थी तो आसपास के पूरा एरिया का तस्वीर बदल जाती थी. अब 400 करोड़ 500 करोड़ की कंपनी लग रही है और आदमी है 4, 10, 15, 20, 25, 30, 35, बस, इससे ज़्यादा नहीं है. क्योंकि सारा प्रोसेस ऑटोमेटिक है, उनको कुछ करने की ज़रूरत नहीं है. सर हमको सिर्फ ये देखना पड़ता है कि जो हमारे स्टोरेज टैंक है उसमें कितना मटेरियल है, दैट्स ऑल. रेस्ट कम पिक करने से लेके फिलिंग तक हमें आदमियों की ज़रूरत ही नहीं है. तो ये जो है ये हो रहा है. मैं समझ गया, आपके सर कह गए हैं सर जल्दी ख़त्म करो. So this is similarly electrocoagulations for stabilized and more pollutant for coagulation participation, forward osmosis for membrane based process, and molecular and portable systems, and thermal hydrolysis, which where we use heat and pressure. This is called thermohydropressure. So we have this type of process. राइट ये आपका इलेक्ट्रोकोगुलेशन प्रोसेस की इक्वेशंस हैं. एनोड पर क्या रिएक्शन होती है और कैथोड पर क्या रिएक्शन होती है. ठीक है, अब मैं आपको वो दिखाता हूँ जो मेन है, बस ज़्यादा मत पढ़िए. ये आप लोग इजीली सब अवेलेबल है ना. ये डिफरेंट टाइप के वो हैं, फॉलिंग फैक्टर्स हैं. मैं आपको दिखाता हूँ क्या पॉजिटिव और क्या नेगेटिव है. बेसिकली वो मेन है. ये मैं वहाँ भी को प्रोवाइड कराएंगे ही ना. बस बस ये देखिए, ये एडवांटेजेस हैं. अब आप देखिए एडवांटेजेस एंड डिसएडवांटेजेस ऑफ एडवांस प्रोसेसेस जो है उसमें क्या प्रॉब्लम है. मेम्ब्रेन रिएक्टर यू आर यूजिंग, एडवांटेज क्या है? हाई क्वालिटी इफ्लुएंट विद लो सस्पेंडेड सॉलिड्स, कॉम्पैक्ट डिजाइन, स्मॉलर फुटप्रिंट्स, एनहेंसमेंट, न्यूट्रिएंट रिमूवल. बट व्हाट इज द डिसएडवांटेज? हायर कैपिटल कॉस्ट and operational cost, right? And then membrane fouling required regular cost. So what it will increase? It increase the cost of membrane and the cost of process, right? So ये जो सबसे बड़ा प्रॉब्लम है ये एडवांस प्रोसेसेस में ये है कि that is not cost effective at all, right? So maximum industry to avoid to use all these process, कि उनको लगता है यार unnecessary we spend crores of rupees in this technology and then again we regular maintenance we require the such amount of money. So they mostly avoid. And reverse bioosmosis, excellent removal of dissolved ions and contaminants, produce high purity waters, compact design, in advanced oxidation process, effectively in break down the wide range of contaminants and no chemical residue, UV disinfectants, chemical free disinfectants, rapidly interaction of pathogen, no residue chemical of treated water, chemical precipitations for effective removal of water and phosphate, simple and wide applications, a relatively low operational cost, ion exchange, selective removal of effective specific ions, effective water softening and heavy metal removers. So this different type and then electrochemicals is effective removing metal, suspended solid, emulsion, no addition, coagulations are required for chemicals, reactive simple operations. For similarly, these are the different disadvantages, high energy consumptions, member foulings, scaling and occurs, high energy consumptions, generally is potential harmful bioproducts, limited potential for depth, initially setup process. Chemical precipitation, general is sludge required is proper disposal, pH control may be necessary. Ion exchange may limited capacity of certain ions, high regeneration chemical use and cost. Electrocoagulation is a high energy initiative process. Sludge handling and disposal may be challengeable. So all these are different advantage and disadvantage. These are the different references which I have taken to make this slide, and thank you. बस इतना बढ़िया नहीं था यार. Now if you have any query we can discuss. No problem. क्या कहते हैं उसको? Session is open to all. कुछ देखिए, आपको रिसर्च करना हो तो सेल के ऊपर काम करिए, बायोरिएक्टर्स के ऊपर काम करिए, इनके ऊपर अच्छा है. ठीक है, हाँ पूछो, सवाल पूछो. किसको? वेस्ट मैनेजमेंट का सबसे अच्छा तरीका स्टार्ट होता है घर से. रीयूज, RRR है ना, रीयूज, रिड्यूस, रीयूज, रिसाइकिल. ये एक तरीका है रिड्यूस करने का. ठीक है, दूसरा तरीका है वो जो हमारे बाबा यूज करते थे, है ना. बाबा के ज़माने में पोल्यूशन नहीं होता था, है ना. सब चीज़ अगर आप उस टाइम के मॉडल को आप अगर स्टडी करें तो आप देखेंगे कि एक गांव जो है वो अपने आप में एक सस्टेनेबल इकोनॉमी था. गांव में किसी को बाहर जाने की ज़रूरत नहीं थी. लुहार भी वहीं पर था, कुम्हार भी वहीं पर था, दर्जी भी वहीं पर था, दुकानदार भी वहीं पर था, बड़बूजा भी वहीं पर था. बड़बूजा समझते हैं ना? हाँ, नहीं समझते पढ़ो. बड़बूजा भी वहीं पर था, सब वहीं पर था, A to Z. ठीक, गांव के आदमी को बाहर जाने की ज़रूरत नहीं थी. लाला जी भी वहीं पर थे पैसे देने के लिए. वो एक सस्टेनेबल इकोनॉमी थी. फिर क्या हुआ? आपकी जो ये पावर थी, है ना, जो आपकी इकोनॉमी थी, जब डिफरेंट माइंडसेट के लोग आए, खासकर वामपंथी जब आए, तो उन्होंने कहा यार ये तो बड़ी गलत बात है. हाँ, ये नहीं चलेगा. ठीक है, उन्होंने क्या किया? सब डिवाइड कर दिया, सब खत्म. और उनका जो वेस्ट है, आपको यकीन नहीं होगा, स्टडीड, न जाने कितने जहाज पानी के हर साल डिसमेंटल होने के लिए, कटने के लिए आपके गुजरात के पोर्ट पर आते हैं. अमेरिका नहीं करता. डेवलप कंट्री क्या कर रही हैं? अपने वेस्ट को इकट्ठा करती हैं, और जो डेवलपिंग कंट्रीज हैं जिनके ऊपर कर्ज ज़्यादा है उनके उसमें लाके वो डंप कर रही हैं. नहीं ज़्यादा हो रहा है तो बंडल बनाती हैं, सी में डंप कर रही हैं. राइट. तो ये जो प्रॉब्लम है ना, ये वर्ल्ड वाइड प्रॉब्लम है, लेकिन हमारे यहाँ ज़रा ज़रूरत से ज़्यादा दिखाई देती है. हमारे यहाँ लैंड के हिसाब से पॉपुलेशन नहीं है, पॉपुलेशन के हिसाब से लैंड भी कम पड़ रहा है। थोड़े दिनों में हम आप सबको डबल डेकर की तरह से चलना पड़ेगा, है ना, एक के कंधे पे दूसरा खड़ा हो गया तब जाएगा, डबल डेकर की तरह से, बचेगा ही नहीं। आज आप चल नहीं पाते हैं, इतना पॉपुलेशन। कोई तरीका नहीं है, घर पे करने का कोई तरीका नहीं है माइक्रो प्लास्टिक्स को। नहीं बताया नहीं जाएगा। नहीं, मैं वही कह रहा हूँ आपको, जैसे जो बंद बॉटल के बॉटल, पानी के बॉटल्स है ना, देखिए हर चीज़ की एक सेल्फ लाइफ होती है, आफ्टर ए सेल्फ लाइफ। अब जैसे आपने बहुत जगह देखा होगा, किसी भी दुकानदार पे जाइए, चाय वाले की दुकान पे आप अक्सर देखा होगा, अच्छा कप, कागज़ के कप में चाय पीते हो, है ना, बस अब आइए यहाँ आइए, आपको पता है उसके अंदर प्लास्टिक की कोटिंग होती है कप में, और गर्म चाय पीते हो आप, क्या होगा, शुरू हो जाता है तुरंत रिएक्ट करना, गर्म चाय उसमें कप में डालते ही वो उसके प्लास्टिक से रिएक्ट करना शुरू कर देता है, ठीक। और आप एक बार पीजिए कोई बात नहीं, बट आप तो रेगुलर पी रहे हैं, फिर आप कहेंगे साहब हमारे अंदर माइक्रो प्लास्टिक चला गया। प्लास्टिक तो आप अपने आप ही कंज्यूम कर रहे हैं। अब वो चाय लाएगा तो क्या करेगा, वो पॉलीथीन में डाल के दे देगा उसको, ले भाई ले जा, होता है ना, क्या कर रहे हो, यही कर रहे हो। और जिस दिन उसको बनते देख लोगे ना कप को, तो हाथ भी नहीं लगाने के, घर से अपने बैग में गिलास डाल के चला करो चाय पीने के लिए, या कप डाल के चला करो, ठीक है। कुल्हड़ में चाय पिया करो, कुल्हड़ में, कुल्हड़ में, कुल्हड़ में। जिसके यहाँ जाते हो ना रोज रेगुलर चाय पीने, उसे कह भाई देख कल से हम तेरे यहाँ चाय नहीं पीनेंगे, कुल्हड़ मंगा, ठीक है। एक बार यूज़ किया फेंक दिया, कोई वेस्ट नहीं, ख़त्म। एक कुम्हार का घर बस जाएगा बेचारे का, उसके कुल्हड़ बिकने लगेंगे। तो आप कुल्हड़ में चाय पीजिए, उसको इंसिस्ट करिए हम पिएंगे नहीं, कप में नहीं हम पिएंगे, बात खत्म होगी। वो बंद हो जाए ज़्यादा बेटर है, क्योंकि वो जो है फ्रेश नहीं यूज़ कर रही ना, वो वेस्ट को रिसाइकिल कर रही हैं। भाई अगर वो वेस्ट को रिसाइकिल नहीं करेंगी तो कुछ और बनाएंगी, कुछ और बनाएंगी ना। अभी हम क्या कर रहे हैं, हम वो वेस्ट को जनरेट कर रहे हैं उतना कि नहीं आप ये बनाइए, मजबूर कर रहे हैं क्योंकि हम उसको कंज्यूम कर रहे हैं, तो वो बना रहा है। तो ये है, ये सर्कुलर इकोनॉमी है, इसको आप समझिए।
Sir, for your widely informative talk, your insights on modern treatment approaches and challenges were truly thought-provoking. I hope we'll stop using the disposable glasses from now on. On behalf of the entire organizing team of the FTP, it gives me immense pleasure in inviting Dr. Swami to present a small token to our esteemed speaker as a gesture of gratitude and appreciation for his valuable time, efforts and wisdom shared with us.